Commission in collaboration with the Ghana Education Service presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission in collaboration with the Ghana Education Service presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission in collaboration with the Ghana Education Service presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission in collaboration with the Ghana Education Service presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission in collaboration with the Ghana Education Service presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission in collaboration with the Ghana Education Service presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission in collaboration with the Ghana Education Service presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next
future generation. Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in
Hello.
collaboration with the Ghana Education
Please, you can all come
The
in.
third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
The Energy Commission, in collaboration with the Ghana Education Service, presents
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel, Kumasi.
The competition aims at fostering an interest in renewable energy.
Let's come in. Those outside, come in and let's continue.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, French Development Agency, and the Volta River Authority.
We are passionate
about the next future generation.
Schools outside, please. Come in.
The Energy Commission, in collaboration with the
Let's acknowledge our sponsors once again. We have GIZ, Love Clean Cooking Alliance, AFD, Bui Power Authority, and the Water River Authority, in conjunction with Ghana Energy Commission. They have made this possible. And then coming with Ghana Education Service, headed by our Director General, Professor Kwesi Opoku Amankwa. And also, to acknowledge the media houses, we have Ghanaian Times FM, Daily GBC Radio, News for Life.com. We are live on Facebook and YouTube. Okay. Now the presentation takes tests from the participating schools. Then after which the judges will use 10 minutes to get some clarifications on your presentations. So contestants, know that you have 10 minutes to present your project, your concepts and demonstrations as to how the thing works or not. It takes 10 minutes, so take note. Okay, so we can also put our mobile phones on silent to avoid distractions. Okay, thank you so much. So the first school, GSTS, please, you can come forward. Oh, let's clap for them. Let's clap for them as they come. Let's clap for them. Good. So you have 10 minutes. The floor is yours. You decide whatever you do with your time for 10 minutes in the presentation. Okay.
Officials from the Ghana Education Officials from the Ghana Education Service, officials from the Energy Commission of Ghana, all protocol observed. Good morning. My name is Kingsley Kwesi Mensah, and I'm with my colleagues from GSTS in the Western region of Ghana. He is Patrick Edem Zebu, Noble Kujo, and Lord Obo. We are here to present a solution which is based on the theme at hand: clean cooking and food processing using renewable energy technologies. First of all, we are going to help you with the problem we identified and our solution to it. Secondly, help you with how our solution works. Thirdly, we are going to help you with the benefits of our solution. And then lastly, we are going to help you with the future advancements. So without wasting much time, my colleague Patrick Edem Zebu will help us with the problem we identified and our solution to it.
The most well-known causes of death in developing areas today are unclean drinking water, HIV infection, and malnutrition. Cooking activities are not widely known as a major cause of death, but there are over 7.2 billion people on the earth today, and a large number of this population engage in cooking activities. Now also, a lot of people also use firewood as their source of fuel, and they get their source of firewood from our trees. and this continuous activity brings about deforestation. Many of the global challenges we face are from what you and I do, and many women and children in developing areas now spend most of their times in the kitchen, and because they use firewood as their source of fuel, it produces toxic gases such as carbon dioxide, which causes respiratory diseases such as bronchitis. Now, there are 70% of the solar energy from the sun comes to the earth, and the energy that comes to the earth in an hour is more than the energy that man uses in a year. But we end up using it to dry our clothes and to dry salted fish, in our local dialect, Kobe. We took a little tour around our remote areas and found out that the effect of this problem was very visible, in the sense that the wooden structures that they used as their kitchens was very black, and the air was saturated with smoke particles to the extent that it hurt our eyes. Pollution cases are very common in Asian countries and sub-Saharan African countries, and Ghana is also included. And there are millions of people who die annually out of indoor and outdoor air pollution. Green energy is an energy which is safe and clean. And can we go forth using green energy to prevent deforestation and to conserve our mineral resources? We took a little tour around the remote areas, and these are our members working on the research. And in response to this problem, the GSTS Robotics Club has brought about a safer and cleaner way to cook and to preserve food using green energy, and that is the Tescan Smart Solar Oven. One may ask, how does this system work, and what makes our system very special compared to other solar ovens on the market? Don't worry about that.
So in response to this problem, these problems, at the GSTS Robotics Club planned on a solution. Our earlier solution looks like this, and now our advanced solution looks like this. Earlier, we placed plain mirrors on adjustable mirror stands, but they were adjusted manually. And so as to improve it, we mentioned we were going to make the movements automated. The maximum temperature we were getting was 100.1 degrees Celsius. We were able to cook rice dough, but it took a lot of time. It took more than 2 hours to cook just rice. Our solar tracker was also part of our earlier project. It was controlled using a remote, but we wanted to advance it. And so we said we were going to make the movement of the solar tracker also automated. We also mentioned we were going to add a thermostat because we had a heating element in our earlier solution to control the amount of current that goes to the heating element to conserve energy. We also mentioned we are going to add an inverter to convert a DC current into alternating current to power our heating element. We also said we are going to add a step-up transformer to increase the voltage of the alternating current to power the heater. We also said we are going to add a solar charger control to carefully take the electricity from the solar panel and then charge the battery bit by bit. So by now, I know you are very curious. I want to know how our brilliant system works. Now, how it works. First, we have concentrically arranged pieces of mirrors, which we strategically place them at angles to reflect the sun's rays to a particular point. That point is called the focal point. Now, this is how our focal point looks like when we test it. Our focal point is 28 centimeters from the surface of the mirrors. We arrange them concentrically to focus the sun's rays to this particular point. Above our focal point, we have an enclosed box. The base of the enclosed box was made from transparent glass. And then the transparent glass allows the heat energy, that is the sun rays, to enter easily onto a black cooking pot. The black cooking pot, we chose that color because it is going to help convert the sunlight into thermal energy to serve the purpose of cooking. We also have a lens at the top. From our research, we got to know that this lens is able to focus the sun's rays to a particular point, and so it is able to burn paper in less than a minute. And so we add this also to a design to contribute to the heat you are getting for cooking. We have a solar tracker, but I'll leave it to my colleague to explain. But before that, let's talk about the automation. Now the question is, because of the rotation of the earth composition, does it mean when cooking a user is to manually control the mirror? No. We solve that by programming on the board, writing a program onto an Arduino board to control. So mirrors will be controlled. So if the sun moves to the east, it also moves to the east, and the sun moves to the west, it also turns to the west, so that our user can be free and then cook. Now there's a question, and what makes our very, very special solar trackers, or as compared to other smart solar ovens? Our solar oven, the question is, in the evenings, can you use your solar? And in the rainy season, can you use it? Let's find that out from my colleague.
Tuscan solar oven is designed in such a way that you can cook during the night and cloud. Most solar ovens would only cook food during the days. And we thought of it that how would we make our project more advanced? So we plan of making a solar panel which received current or receive energy from the sunlight and convert it to electrical energy. This solar panel is made as a tracker to follow the direction of the sun, to energy from the sun as well. So as it receives energy from the sun, there is a battery which is being charged by the solar controller. The solar controller charges the battery in such a way that the battery will overcharge. Also, we have an inverter built by us in our battery compartment. The inverter converts the alternating current into direct current into alternating current to power the heating element we have here. For fridge that, as a point that heating element requires alternating current to heat the food inside. Also, we have a thermostat is there to control the temperature inside the box. The thermostat is able to control the temperature inside the box. That means when your food is inside the box, your rice is not going to burn and your plantain is also not going to burn. We also have a temperature display that displays the temperature of your food inside there, which means that you can know that my rice is being boiled at 72 degrees Celsius. How efficient is Tuscan solar oven? Wait and let's watch.
How efficient is our oven? Our smart solar oven, go for it. Our smart solar oven was able to burn a very hard paper. From our research, we got to know that paper burns at a temperature of 248.889 degrees Celsius. And then ours is a very hard paper. And so imagine the temperature. It is over 248.889 degrees Celsius. It was also able to cook rice. We cooked rice this time at a much faster time. It was less than 1 hour, but for our earlier solution, more than 2 hours. And so we have indeed advanced it. It was also able to boil egg. It was also able to roast corn. Yes. No, there's no video. Okay. Now moving to the future advancement of our solution. But before that, let's look at the benefits of our solution.
Okay, to the benefit of our solution.
Thank you very much, GSTS. I think they deserve a round of applause, please. Can we do it for them? I have two very simple but quick questions to ask. I just want clarification. The first one is, what was the exact time that your system used in cooking the rice? Because I didn't get that one. Even though I know the first one took about 2 hours. With the current situation, what was the exact time?
So before you placed the food into the enclosed box, we told our media team to come and record and then look at the time, but they didn't come out very early. But certainly it was less than 1 hour. It was actually about 40 to 45 minutes.
All right. So going forward, as you use it, we expect that you should be very consistent. All right. It helps when. Well, to the last one, I would like to know. Hello. So, what kinds of food do you think we can use your system to prepare? That is, if you have done any, actually.
Okay. Our solution can be used to prepare a wide range of foods. It can even be used for baking bread, and for baking pies. It can be used to cook rice, egg, and staple foods.
The one.
Okay,
You're right.
Yes, sir. We cook rice, we roasted corn, we boiled egg, and yes, so that's all.
Okay,
yes.
So I would have been very happy if you tell us the time that you use to prepare each meal. Because if I'm of my plantain, I'd like to know how long it will take if I use it to prepare my plantain. Thank you very much, and that'll be all.
Thank you very much, GSTS. It was a good presentation. We would have loved to have the full presentation, but time was not on your side. I have a few questions for you. The first one, I want to find out from you the distance between the collector and the utensil or the receiver. What is that distance?
So the focal point is actually 30 centimeters, but because our box has to come down, we reduced it by 2 centimeters, so that our cooking pot, the focal point will have direct contact to our cooking pot. So 30 centimeters. Centimeters. Yeah, this is the collector. It's the same as the oven. The collector and oven.
Yes, that's the optimal distance
of the focal point.
Good. You have introduced an inverter and a transformer.
Yes, sir.
I would want to find out from you, this is physics, the output voltage of your inverter, and if you transform it, what voltage are you expecting?
Okay, so the battery is 12 volts, that is direct current, and the transformer transforms the 12 volts to 190 volts. That is after it has been turned to AC. The inverter converts the direct current to AC current, and the transformer steps it out from 12 volts to 190 volts.
Mean the inverter is only inverting your DC to AC, and the output of the inverter is correct?
Say, the output of the inverter is the transformer is part of the inverter, so the transformer steps up the 12 volts to 190 volts.
So inverter that converts the DC to AC with an output voltage. You indicate that this is green energy, and you are able to use it not only when the sun is up. You're able to store energy and then use it throughout the day. You stated that user has the flexibility to go around the system. Have you taken into consideration the effect of shadow? If the user is to go around the oven, what will be the effect of shadow on the amount of energy you're able to extract?
Sir, please, you said the shadow casted by the user. Sir, we've made our system automated. That means the user doesn't have to stand by it. It's just automated, so you just place it in the sun and it will be able to move in the direction of the sun. Is it on?
Yeah, then do it. It's off. It's okay.
So you
Yes, sir.
track the sun without the user going around it. Thank you very much.
Yeah, thank you very much, GSTS. That was a. I want to follow up on the optimal a prototype, and obviously this does not cook. It's very small, so you gave the distance between the your collector and then your cooking pot, but it's just for your have it. If you are scaling up, when you are scaling up and you have your collector pot bigger, I thought the collector and then the pot scale up. I was expecting something like that, but you only gave stands for this one, which is clearly a prototype. That relationship
principle. We use lasers in identifying the strategic angles at which the mirrors are being placed. And so to scale it up, we are just going to use that principle to get the required angle, that strategic angle, to get the required focal point. No, sir.
Sir, please, the angle of the mirror determines the focal point. You see, the mirrors are strategically placed in this angle with the lasers. So all of them is being focused at that particular point.
How simple is this for assuming you want that to adopt this for, say, for baking or cooking rice? How simple is this?
Sir, please. The user doesn't have to stand by the food to actually lowering the temperature and increasing the temperature, because it has a thermostat here which actually lowers the temperature and increases it. And we've also added buttons here of which the user can set the temperature to his temperature. As in, you want the thermostat to cut when the temperature gets to maybe 100 degrees Celsius. So that's what makes our system easy to use by the user.
Cost compared to other technologies.
Thank you for your question. Compare this project that you have to other conventional cookers. You can see we used local materials such as plywood, box, lens and mirrors to make it. So it is very low to make it. Very, very, very low. It doesn't require any special skills to operate the cooker.
Please, if I understand you, because our system is made up of wood, it wouldn't last longer. So we should, maybe in our advancement or to the public world, it should be made of metals so that it can, last longer. Equally, these stands can be made of the woods, and just this box will be made of metal for a larger scale.
So how are they hybrid?
Yes, sir. Thank you, sir. So our solar tracker, which comes with a solar panel, takes the sun rays and then converts it into electricity. And then it charges a battery, but it first goes through the solar charger control, which charges the battery bit by bit. And from the battery it goes to the inverter, which converts it to AC, and then the transformer steps it up. And because of our heating element, we want AC, and heat elements require AC to work, to function effectively. And so with that one, it can be used in the evenings, but in the direct sunlight, the rays are being entered, the rays enter our transparent glass and then goes into box. And then while in the rainy day, the heating element can still support heating.
System what is supposed to be?
Yes, sir. Yes, sir. Thank you, sir.
Thank you very much. I think it's a very innovative project. One of the setbacks for solar cookers is the fact that you are not able to use it when the sun is not there, and you have thought around it to use solar cells to store energy in batteries and then discharge it in the form of electrical energy to get your heat energy again. That's quite innovative. You still have a lot to do around this. You need to look at the efficiency in all this configuration. You know, how much efficiency are you getting in terms of overall efficiency for the oven? I think it's a technology that may have a good application in our settings, in the sense that we have a lot of bakeries, in this country that are using LPG and firewood. And if we can work on this, it will go a long way to address some of the climate-related issues that you pointed out. So thank you very much. I'll hand it over to my colleague.
Thank you very much, GSTS. You are duly discharged. So whilst GSTS is leaving, shall we please, with a round of applause, also welcome Infanteman girls.
Mr. Chairman, educationists and technocrats present, ladies and gentlemen, I am Mohamed Nayabwa, and I'm here with Tiane Free from Infanteman Senior High School. We are here to present to you our project on clean cooking and food processing using renewable energy technology. Now, clean cooking is the use of cooking processes and technologies that do not pollute our environment. The name of our project is the site digester and stove. Table of content: 1. Introduction. 2. Intervention. 3. Theoretical framework. And 4. Conclusion. Now, to the introduction, we have statements of the problem. 1. Global warming and climate change. The release of harmful gases such as carbon dioxide, carbon monoxide, and methane into the atmosphere trap ultraviolet rays that must escape the Earth's atmosphere. This leads to the heating up of the Earth above its normal temperature and eventually melting of the polar ice. 2. Depletion of forest. In Ghana and Africa, charcoal and firewood are the major sources of fuel. In the production of charcoal and firewood, there is the felling of trees indiscriminately, mostly without replacement. Every year, 4.4 million trees are felled, and 72,900 hectares of land are cleared for firewood and charcoal. The burning of firewood and charcoal leads to the release of these harmful gases into the atmosphere to cause pollution. Our final problem: open defecation and waste management. Now, the West and Central African region accounts for 24 global open defecation, with 120 million people practicing it. In Ghana, as many as 5 million people practice open defecation, and this leads to insanitary conditions in our environment. Now, moving on to the description of our project. Our project is made up of the Infanteman biodigester, the side stove. The Infanteman biodigester is a plastic compartment into which cow dung is poured to undergo anaerobic digestion in order to release methane gas. The harvester is a rubber tube for the collection of the gas produced, and the side stove is the stove that will be used for cooking with the gas generated. Now, how does our project help solve the problems mentioned earlier? In the production of methane gas, the gas will not be allowed to escape into the atmosphere to cause global warming and climate change. Instead, the gas generated in our project would rather be trapped, and it will be used as the fuel for cooking. Secondly, people will purchase the methane gas since it will be produced at a very lower cost instead of going in for the charcoal and the firewood that leads to the depletion of our forest. And finally, people will be encouraged to use public toilet systems instead of wasting openly, since that excreta can actually be used to produce methane gas for cooking.
Aims of the project: 1. To combat climate change and global development goal 13. 2. To help end deforestation and restore degraded forests, solving 15.2. And 3. To open education and provide access to sanitation, solving SD 6. Our intervention origin: this idea was originally from Bombay in India in the year 1859 and was later adopted by Europe in the year 1895, currently used by 2 known European countries, France and Germany. How renewable? In our environment where there's abundance of biodegradable materials, talk of human and animal excreta, as well as kitchen waste, this is an assurance of continuous production of biogas. How clean? As compared to the production of LPG, in which every stage of its production releases harmful gases like sulfur dioxide and carbon monoxide into the atmosphere. In the production of biogas, the gas emitted is trapped, and that is the fuel needed. Feasibility: in our country, there already exist public toilet systems, and this could be used for the production of biogas, even in our senior high schools.
Mr. Chairman, permit me to submit a diagram representation of the biodigester. The production of the biodigester: holes were drilled in various parts of an empty gallon. PVC pipes were fitted into the holes drilled. An inlet was created as a passageway for fecal matter to get into the digester. An outlet was created for the situation where the digester has to be emptied. A degasifier or soakaway was created when the fermentation takes place and the excess water has to leave the digester. Delivery tubes connect the digester to the harvester. Generated leaves the digester, which is highly concentrated, to the which is of lower concentration by the principle of diffusion. The delivery tube is connected with T-valves and regulated. The side stove. The stove was made in collaboration with the Visual Arts Department. It consists of clay components and metal components. With the help of ceramic students, the clay components was thrown on the potter's wheel to get the cylindrical shape, and the metal components were fitted into it when it was leather hard.
The theoretical framework: anaerobic digestion. Anaerobic digestion is a sequence of processes by which microorganisms break down biodegradable materials in the absence of oxygen. This occurs naturally in the within digestive system to the depth of effort and produce artificial engineered containers called digesters. On the average, biogas contains 55% to 80% methane gas and 20% to 45% carbon dioxide. LPG versus biogas. In the production of LPG, how into the atmosphere, but in the production of biogas, environmental reduced to a certain extent. Secondly, the cost of production of LPG is relative to production of biogas. Why clay? The more clay is subjected to heat, the harder and stronger it becomes. Cement contains clinker, accounting for its inability to withstand high temperatures. The benefits of our project: 1. It provides a cleaner environment. 2. It will serve as a source of employment. And 3. It will serve as a source of organic fertilizer. In a case where enough gas has been collected through the degasifier, the water can be passed out for the production of organic fertilizer needed by plants for optimum growth and development.
our project. In as much one, it will knowledge in its production. It produces methane gas. And 3, temperature range for production of biogas. If the temperature range does not fall between 80 degrees Celsius and 60 degrees Celsius, the microorganisms efficiently. Conclusion and recommendation. Why buy into our well, based on current trends and progress towards SDG 7, by 2030, there will still be more than 2 billion people in Africa still relying on traditional biomass for cooking. Our project is clean, affordable, and accessible. Therefore, we recommend that governments, NGOs, and stakeholders in the energy sector would consider our project as a better alternative source of fuel for clean cooking. Our budget was 1,800 Ghana cedis. And these are references. Now, Mr. Chairman, we would like to demonstrate how our project works. Please, can we have the lights turned off, sorry, to show the film. Methane produces blue flames on fire. That is why it's not really visible. This is the blue flame because it's methane gas, so the flame. Please, we want to show you more. Thank you very much.
Infantiman girls, thank you very much. That's a wonderful presentation. I have 2 questions. Number 1, tell me what is innovative about your project.
Thank you. Please, the fact that it is manufactured with local materials such as gallon, clay, metals, and the harvester. That is the only thing that we bought. Apart from that, the rest was local materials. Please, on a large scale, there is a manufactured biodigester that is used to produce methane gas on a large scale.
Manufactured digester?
Yes, please. This idea is not originally ours. It is already existing, but it is not recognized in Ghana. So we want to draw people's attention on the fact that it can be used in our country.
Oh, so it's not about technology development, but about awareness.
Please, you said.
So it's not about developing some technology, but awareness. Is that what your project?
Thank you for the question. So, technology is increasing, but it seems in Africa we are trying to go blind on it. Only trying to add and to pay to the side of technology in order to produce clean environment, not to make our cooking very clean.
You mentioned something about open defecation, and you said your project would solve that. I don't know, there are already public toilets around and people still choose to open defecate. Why would they not open defecate? Because of some gallons you have set up somewhere. And people cannot sit to defecate anyway. So how do you...
Thank you very much. In the public system that already in Ghana, we could just and they collect the human excreta for the production of biogas.
You connect to the
idea would be adopted so as part of the public toilet system to for the collection of human production of biogas.
And then I pump into the pump from the public toilet into your garage.
Oh please, this is acting as a septic tank.
So I'm thinking of constructing some concrete structures or
because the heat in the septic tank, gas will be generated and this encourage people to use the public toilet because it's free and it will be relatively because public toilet.
last one. Since we mentioned oxygen-free technology, if it's a system, and obviously there will be some oxygen going into the system. How would that affect its performance?
Inside the septic tank, there's no oxygen going into the tank. It is a tight, closed tank compartment, therefore there will be no oxygen which can enter it. And then when you put the septic tank, there's constant temperature, so there will be enough for the microorganisms.
All right. Thank you very much, Infantiman, for your presentation. We've enjoyed it. It was a good presentation. A few questions for you. One, I want clarification on something you said. You indicated that about 4.4 million trees are cut down every year. Is it for the production of firewood and charcoal? And does this represent the global situation?
Thank you very much for your question. Please, according to our research, we found out that in Ghana, 4.4 million trees are cut down for firewood and the production of charcoal. That is according to our researches.
Can you the source?
UNICEF is part of our references on the slides.
Okay.
Yeah, welcome.
I have a couple of questions now. Apart from temperature, what other factors would influence the production of biogas? No, I said apart from temperature, what other factors influence biogas production?
Thank you very much. Please, as there are and also,
thank you very much. The molecular mass of methane gas is 16 grams per mole, and as compared to the molar mass of air, which is 28.8 grams, is going to make the methane gas escape. So that could be another
I'm repeating myself again. Maybe if the question is not clear, please, can you give us your audience? You have the opportunity to educate us. You mentioned that you need a temperature in the range of 20 degrees C to about 60 to be able to produce biogas. And I want to find out from you, apart from temperature, what other factors are necessary for the production of biogas?
thank you very much. Please, other factors influence the production of biogas is enough pressure, then the gas will be able to move out from the digester into
Thank you very much. You can clap them. Typically, what should be the retention time? Retention time that you can hold your substrates or your feedstock in the digester. Retention time.
Thank you very much.
See, you would read around that, okay? So thank you very much. I'll hand it over.
Thank you very much, Infantiman girls. I have just two very simple and straightforward questions, okay? Just two. The first one is this. I am looking at your stove, right? And I am thinking, wouldn't I just connect my gas to any of the existing gas stoves and use and get the same benefit as compared to using your stove with your gas? Is there any special benefit for that? I want to know.
Thank you very much for your question. Please, connected to the stoves that we use in our various homes. The clay was
Oh, okay, so it wasn't for any special addition. Okay, thank you. And then the second one I wanted to find out would be, in a normal day or probably a normal period of constant, let's say, cooking of rice, how long would it take? How long would it take for one of your storage tubes to be emptied?
So normal time that we use for cooking, but ours is just a prototype, so you can't rely on it to actually cook rice for it to be well cooked, because the gas will finish a maximum time.
Okay. Okay, I wanted to be sure something. Have you actually used it in trying out some foods? You haven't?
No, please.
Okay, thank you very much. All right, so on that note, that will be all from Fantiman girls. Shall we please give it up to them?
Thank you very much, Infantiman girls. And we will invite Methodist Girls Senior High School to come upstage. Let's put our hands together for them. As they come forward, a very quick announcement. And this announcement goes to our coordinators and teachers. I believe that we've done wonderfully well in preparing our students for this challenge. Please, the moment they come, your work is done. Your work is done. Just leave them to do their own thing. We don't want to see you trying to communicate with them. All communications should cease as soon as they start or they come up stage. I'll be looking around for any form of communication. If I see that, judges, I'll let you know, and then you penalize the school with 50 marks. 50. And for this, I'm being serious. No communication.
if I see any form of communication with the student, especially during the questions time, that would 50 marks. Your school will be last. So let's take note, and I'm going to enforce this strictly. Thank you.
Start. Hello. Okay. I'm okay. Good morning. Oh. Hello. Okay. Good morning. Hello. Okay. Good morning, ladies and gentlemen. We are the McGee's Young Inventors, and we feel honored to be given this opportunity to present to you a project on the topic clean cooking and food processing using renewable energy technologies. I am Denise and Odemans here with and here we present to you our mind-blowing project. And this has sought to manufacture a high-quality, affordable, and movable solar cooking device to ending dependency on LPG and electricity. And we want to make Ghana the #1 manufacturers of this device, as well as the #1 producers. Coming down to our current situation, where we see our women in the rural areas, as well as our sisters, even us in our homes, use firewood and charcoal, and it has become a dominant practice, leaving us prone to this. How do you feel knowing you can make a change? We need to make a change. To make this change, we need renewable energy. Then it's renewable energy. Renewable energy refers to resources that we can use over and over again with the knowledge that we can replenish them within a short period of time. They produce clean energy, causing no pollution. Examples are biogas, wind energy, solar energy, among others. According to a research article published by the International Journal of Environmental Sciences, about 90% of the households in Ghana use firewood or charcoal for cooking. Also, about 68% of the Ghanaian population live in rural areas where biogas constitutes as a major source of energy for household use. Our problem solve many problems, but the two problems that we intend to address are: 1, to reduce the air pollution and food contamination rates, and 2, to decrease the overdependence on LPG and electricity. Our objectives are to: 1, to create a highly affordable and quality parabolic solar cooker with raw materials involving scientific technology and knowledge to salvage the never-ending dependency on electricity and LPG, and 2, to promote the usage of renewable energy resources. With this, we would like to explain the concept behind our parabolic solar cooker.
Judges, audience, let me introduce to you our parabolic solar cooker. So, a parabolic solar cooker is essentially a solar cooking device, which is a solar thermal collector used to cook or pasteurize water. It could be used to cook food as well. But there is a pretty history behind the parabolic solar cooker. This parabolic solar cooker was first documented by French Horace de Cicero in 17. It works based on the principles of reflection of light as well as heat transfer through radiation and now the materials used in making this nice invention, audience, it will concern you to know that this is renewable because it depends on the sun, that is the solar energy, which never runs out. And moreover, we didn't use any expensive things in making this invention. We just got our aluminium foil tape and applied it on a discarded satellite dish. Moreover, we decided a nice stand for our dish to support the dish as well as our cooking pan. So over here we have the receiver, and then here is our satellite dish. Now let us look at the principles behind it. I mentioned reflection of light initially. So the rays are reflected from the sun and they incident on this parabolic satellite dish. The ray incident at a point called the focal. That is, all the rays incident from the sun converge at that particular point, which is the focal point. Now it's being transferred through vacuum, that is known as radiation, and then it is also transferred through conduction, that is through the metallic stand. Now this we found the focal length. The focal point is necessary because you have to know the right and appropriate place to fix your receiver. So you would ask, why didn't I take the receiver back? Why did I choose this particular measurement? It is based on the inverse square law, which states that light intensity is inversely proportional to the square of the distance. Now, let's look at how this could be used to prepare food. It could be used to prepare any food. In our school, we prepared akple, that is, we boiled water and then we kept in the food. So there is a picture of our teachers enjoying this beautiful delicacy, a sweet meal. Yes, so it could as well be used to prepare boiled yam and any other food. All you need to do is to drop parabolic cooker portable. You don't have to carry it, which means our old women can use it. When you drag it under the sun, you make sure it's facing the direction of the sun. One may say the sun will always be at one place, and that is why this is so you'll be able to face the sun and it will prepare your meal for beside our school, so and some people still prefer the use of gas cooker, but there were only 3. Most people were very impressed with our invention. Of which audience, you are also impressed, right? I'll hand over to my colleague who will take us through the benefits of this product. Wonderful.
Portable and it's affordable and easy. It's portable, it's an affordable and easy to use. Am I right, judges? Convenient. It can be afforded by anyone in our rural women in the village, but as the saying goes, to every advantage is another disadvantage. And these are, it can cause eye injuries, but that is why my Valen team of sisters and I have come up with some principles to solve these issues. And these principles are 3 to help protect the operator from any injury from radiation. And these are justification. Justification deals with the determination of whether or not the radiation produced affects the operator negatively. And then we go to optimization. Optimization is the process of protecting the operator to reduce the dose as low as reasonable as possible. Dose limitation. Limiting the dosage is very important to protect the user from the negative exposure radiation causes to the skin. And also some practices can also be made to minimize this effect. Time. It's very important, dear audience, time which is spent in contact with the material. It's also important to wear appropriate clothing which involves shielding when working with this material. And also the operator must be at an appreciable distance away from the device when in use. And this, my judges, makes this a very easy product to use. It's very wonderful, affordable, and good.
Coming down to one conclusion. Do you want to cut down your cost every month? Do you want to help our women and sisters? Do you want to make a change? This is clean cooking. Energy Commission, this is the device you need. Thank you.
I just forgot to say.
Thank you very much. Megis Manfi. Is that correct?
Yes, please.
Okay. It was a very nice presentation.
Thank you very much.
You might capture my attention throughout your presentation, which was very good.
Thank you.
I have one or two questions for you. You talked about the focal length, and you gave us some function for that. You said the focal length is determined by the product of RC divided by 2.
Yes, please.
Can you explain what R is and what C is?
Okay, so our parabolic dish has the shape of a lens, which is curved. So RC is the radius of curvature, of which we found to be 85. Hence, to find the focal point, we divided the 85 by 2, giving us 42.5. And then 42.5 is the distance between the receiver and the parabolic dish.
Good.
Please can you come again with the question?
If you want to increase the amount of energy that you can trap from the sun and concentrate it to the saucepan, which of these two factors would you, or parameters, would you consider?
We would be considering the inverse square law, which states that the intensity is proportional to the square of the distance. Simply, when the distance is very far, the intensity is smaller. But then when you bring it closer, the distance becomes small, the intensity is greater. And what is so interesting about this is that it's movable. So if you realize that the radiations are not getting to this point, you can move it forward. Thank you.
Now let's come to the social side, the cultural side of this.
Yes.
You put some accolade for your teachers.
Yes, please.
Very well. If your teachers want to eat accolade in the evening when the sun is coming, how would you address that?
Thank you very much for that question. Yes. So to address that, even someone will also say, I wouldn't like to stand outside to be cooking. And that is why we researched and we found out that we can use a solar panel and we could as well use lithium cells. But unfortunately, the school couldn't fund that. But in the future, we have also started a research to make DIYs to produce our own solar panels. Yes.
Dear sir, please. Dear sir, please, as you said before, we are willing to cooperate the use of lithium cells to store the energy of the sun in times of the night, in times of rain. But since we don't have that, and it's the evening, we could also get a very high-powered bulb or a very high-powered torch to reflect.
We are not discussing science.
Yes.
Social. Cultural.
Yes.
Your device has a limitation. How do we ensure that our activity is available in the evening?
Okay, sir. Thank you for the question. So like they said, we want to trap the energy, but we want to convert the solar energy to electrical energy. It will be like an attachment piece. So when an attachment piece.
You asked us a series of questions, whether we want to accept it or not. You need to communicate. Yeah. So I'm still giving the opportunity, the last opportunity, for Forget about the science. We are looking at within the limitation of this device, which we pointed out clearly.
Yes, please.
We, the judges here, want to ensure that in the evening, when the sun is not there, we can still have our food. From a social point of view, how would you address that?
Further advancements, we plan to solar panels to the parabolic solar. We plan to attach solar panels and a lithium cell. For further advancement, we plan to make this like a heating pad. So let's say in the afternoon when you are cooking, as you cook, the solar panels will store some of that energy, store it in the lithium cell. Then in the evening, you'll be able to transfer the energy from the lithium cell to the heating pad so that in the evening you can also cook.
The marketability, the acceptability of this technology. Marketability, acceptability. Taking this product to the market, the buyer knows that in the evening, he or she cannot complete. If the buyer wants to ensure that at all times there is food ready to be eaten, what would be the message that you can give to that buyer to help him or her ensure that there is food available to eat at the time this device?
Okay. Dear sir, I think I get your question. So first of all, we gave you with the poor package, we want to give you the manual. And first of all, you know that you're supposed to cook at a certain time period. So using the manual we're giving you, you're supposed to have the knowledge that you're supposed to cook at a certain time period. And in addition with the solar warmer which we bought, you can store that food in the solar warmer so that in the evening when you are ready to eat with your friends, you bring it out and the solar warmer can store. Okay, thank you, sir.
All right, thank you. You asked who your target market is. I want to be sure whether I heard you right. So, who specifically are your target market?
So we don't have a specific target market. It can be used in a lot of places. It can be used at the beaches. It can be used at restaurants. It can be used at picnics. You have family eat out. All sorts. Yes. So.
Then the next one I'd want to find out from you is this. I am thinking, and I don't know, you were also mentioning that one, but I didn't get your point very clearly. Considering me going to prepare the akpele that you prepared for your teachers, because honestly, I would have loved to see a view of you preparing the akpele, then I can understand. Because I'm just looking at how it's going to be. I'm going to prepare. We are
End of the life for us. Thank you. And bring the song as well. Sir, as you mentioned earlier, it's portable, it's adjustable both on the top and the bottom. And using this flashlight, show that, look, it's reflecting onto the pot. Sorry for the low light intensity. It's reflecting onto the pot. So within an amount of time, which we measured during that time period, it got heated. And you know that it's sorry for mentioning wrongly. It heats with water. So when the water got heated, we put the items into the pot. And then with gradually a time period, it got heated, and we can't on the thing. So sir, as for available at the moment because it was an impromptu something, but we assure you that if there was enough sunlight here, we will demonstrate it to show our credibility, to show you that it's cook this thing. So I believe this is a very marketable.
Thank you.
Future.
The very final one was I am always thinking about those who don't really
understand all the sciences that you are applying. That is exactly why I was just thinking. I wanted to see, how the person appeared, because you talked about some other things that will happen in terms of the eyesight, in terms of the heat and all that. So I wanted really to see how the person approached the system in order to prepare the food. It gives me a position to explain, to consider food. Anyway, so,
she wants to explain that.
Please, with the problems associated with this, it only occurs with the prolonged usage of it. So we recommended the protective things specifically for commercial users, those who use it in commercial purpose. But with us using it, all we needed was it. That would only be when the intensity of the sun is very high. But on a normal day, it will still work without. So in preparing our acne, we heated the water up. And when the water was very heated, we poured the flour into it. All we needed was to stir. So the stirring of this didn't take more than 3 minutes. So it wouldn't really affect us.
And so there's also something also that we're supposed to know. Ionizing radiation such as X-ray and gamma rays that affect the body negatively. It's equivalent to standing in the sun for 10 consistent days. So that's how minimal the effects, the negative effects of this are. So if you stand in the sun for 10 consistent days, that's equal to the effects of X-ray and gamma rays. So it has minimal disadvantage. Thank you.
I allowed to.
Yes.
We know how acne is prepared, right? Somebody has to really, this looks weak. Somebody has to be, maybe you turn on something and then do the stirring, right? How are you prepare acne with this? And you mentioned 3 minutes. Nobody prepares acne in 3 minutes. It needs more time. We all know, we prepare TZ, Bankun. How are you able to, stir this with the water boiling? So, that could.
Sam, please, as for mentioned, yes, as for mentioned, we first let the water boil before we pour the components into it.
We have tried this.
We could demonstrate it for you
and then turn food on this. The picture to see exactly. Anyway, I'm sure. I want to go to your program. According to somebody, 90% so in Ghana. From which?
90% of the households in Ghana use either firewood or charcoal for cooking, according to a research article published by the International Journal of Environmental Sciences.
Yeah, that article published. This is not.
Yes, with this considering how tough our economy has become, people are, first of all, the cost of LPG is very expensive nowadays, and more encountering these expenses, utility to your homes, and we keep recording stories of people's houses getting burned, people losing lives and properties. So we thought about reducing such risks.
So how do you expect the rich households in? We are it's a very rich community of LPG or electricity.
Okay, we can still depend on LPG and electricity. This is it's like a support material. You don't always have to depend on LPG and electricity. The solar energy we get from the sun is free. You can't say that you always, let's say you want to pound fufu. You can keep your silver here, boil the water, put the cassava in while it's being cooked, then you can prepare your soup. It will help reduce the cost.
How does that happen?
Sis, would you do that? By commercial. So you radiations which will kill our immune system at encountering.
Okay, last one. And then you mentioned that you must put appropriate clothing when cooking. Does it mean that, I mean, once you're eating this every day,
because we personally, when we're preparing, we need clothing. The protective clothing is necessary for commercial users because commercial users will be working more often, that is exposing them to more radiation. But the protective clothing is to help radiations you are being exposed to.
Just suggestion. If you have the chance to present this at the national level, you should be thinking of probably, because of all the social and cultural issues surrounding this technology, in heat exchanger at the receiver point, so that the heat which is concentrated, the use it together with LPG, gas, concentrate the sun to the heat exchanger. You use a whatever means in gas to transmit that heat to a more conducive environment, and then you use it to preheat. After that, you apply the LPG or whatever other fuel you want to use, and that will save you so much. You can look at the science behind it and look at the economics behind it. That is very innovative. The major challenge that this thing is facing is the social acceptability and also the scalability. These are the key constraints with this technology. So I hope you can take this on board. Thank you.
Thank you very much. And with this, you are duly discharged. Shall we please give them applause? We welcome Busek. Boyman Senior High.
Hello. Hello. Yeah. Caleb. Good afternoon to you all. This is Tim Busek. We are here to represent on the team Clean Cooking and Food Processing using renewable energy and technology. I'm Bonnie Barbara. Yeah, my colleague.
Lagojima Oli. Tete no colleague. Nani Samu.
Our main aim is to ensure clean cooking by using the 8-plug solar cooker. Over recent years, research has shown that most people mainly depend on firewood and charcoal to cook. This has imposed a very great side effect. For instance, cutting down of trees for charcoal may lead to respiratory diseases such as asthma, lung cancer, and bronchitis. Someone may ask, what is the 8-plug solar cooker? The 8-plug solar cooker is a device that converts thermal energy to electrical energy. It gives us another approach to rely on the effective useness of the sun. It has photovoltaic cells which generate electricity for each halving of the production.
Here we have some materials we use here. We use a battery which is supposed to be a solar battery, but because of financial constraints we use a car battery provided by a school bus. Then we have solar panel controller, a switch, heat plus, their tray, and an aluminium that we connected a heat plug on. And we have connecting wires and a solar panel, a 12-volt solar panel, 100 watts. I hope he has said everything about the heat plug solar panel, but the heat plug solar panel is something very interesting, and from the look of faces I know people would like to know. People would like to know much about the heat plug solar panel, solar system. And the heat plug solar cooker has an oven, and in this oven, as you can all see, there is an aluminium here and there's heat plugs, and mostly these kind of heat plugs are being found in car engines, but here we are using the heat plugs here. Okay, so now this is the principle or the mode of operation of our system, or this heat plug solar cooker. Now we have a solar panel, and as we all know, the solar panel contains photovoltaic cells, and these photovoltaic cells, upon trapping or upon receiving solar energy, converts this solar energy into electrical energy. And how? It is by a phenomenon called the photoelectric emission or photoelectric effect. Since the photovoltaic cells sometimes are called, we have the photovoltaic cells to be silicon. Silicon is a photovoltaic cells and normally use preparation of the solar panel. So when light strikes it or when the sun strikes it, it absorbs the solar energy and by produces movable electrons to produce current, and this type of current I'm talking about is a DC, a direct current. So now these direct currents would flow into or to be stored and charge our battery. It should have been it should have been a solar battery, but due to financial constraints we are managing the car battery. So the DC current produced by the panel being stored here or charges this the battery. And there's a regulator called, or there's something called the PWM solar charge controller. And what this solar charge controller does is that the solar charge controller controls or regulates the flow of the DC current from the solar panel into the battery. So that means in the case of charging it, in the case maybe having overcharging or something, it is this solar charge controller that is regulating the flow of the charges. And we also have a switch, and the switch opens and closes these circuits. When it closes, that means there is a free movement of electrons. The free movement of current, that's a direct current from the battery onto our stove. So now, in the stove, as you can all see, as I said earlier, there are heat plugs, and these heat plugs are normally found in car engines, used to heat up, used for heating the car engine. So we use these heat plugs to generate heat or to convert the electrical energy into heat energy, and by a form of conduction, it will transfer the heat energy onto the saucepan or onto the pot we use to cook. So now, when the currents are, we have the terminal. So since it's a direct current, it has terminals, positive and negative. So now the negative terminal has been connected, and then the positive terminal to the plugs, all the three plugs. So now, when we have also a coiled wire here, and these coiled wires that you can see visibly, this coiled wire, upon being connected to the terminals, gives or provides the current for the heat to function or to produce the heat. And when it should work, or when it produces the heat, all the tips turns very red, intensely red, as you can see on the slide. So the tips here can all be red, and it becomes red because of the coils around the heat strap, the heat plug, sorry. So it gives the current, or it flows current or transfer current onto the heat plug for it to convert the electrical current into thermal or heat energy. So as you can see red like this, it is the accumulation of heat at the tips, and by convection or conduction, it will transfer the heat here onto the saucepan for effective cooking. So this is how the saucepan is, and when the saucepan, we put it here for the conduction to occur. But most of the times, for effective conduction, it should have direct current onto the plugs, so that there will be effective conduction of heat onto our saucepan for cooking. Okay, so now the heat plug is being designed in such a way that it can be used very effectively. So we tried using the heat plugs to create something like this, so that we can convert this electrical energy into thermal energy for the conduction into the saucepan for effective cooking. I hope everything is understood for the mode of operation.
Thank you. To continue, this one, it has an advantage, and the advantage that it is cheap and easy to use. Also, it increases productivity. We know in Ghana here, we are describing it in depth, and it increases productivity in the case that in the era that our ladies will go to the villages searching for firewood. This one, you not search for firewood, which will waste your time, but you just be in your room, just put it on, then you cook your food. And to study statistics, you can use 25 minutes to go to the farm, search for firewood, and can prepare, or you use 50 minutes. But in this one, you're just going to use 10 minutes to cook, 10 minutes to start the process and in cooking. And also, it is safe to rely on. That's something that everybody can use it, and it can be used to cook all kinds of foods. And we try using to cook rice, and it works effectively. So these are the steps that we use in cooking the rice as an evidence. So this is the heat plug. So this is after the rice that we cook. So this is the heat plug, the filament. So as it becomes hot, and you put the pan on it by thermal equilibrium, heat loss is equal to heat gain. So the heat loss here will be equal to the heat that will be gained here to cook the food for you. And also, in everything we had disadvantages too. And the disadvantage we had in doing this is, you see, we are science students, and it's not now we know. We are just our idea to in brain about this thing. So as we are trying to try about 3 experiments, and our last experiment, that was Thursday to Friday, we come to this experiment. We use it for cooking the rice, and it took time. It's like 45 minutes. The rice was ready, and realized that the cable start melting. So as the cable start melting, we were fumbling among ourselves. So we asked ourselves what would be the cause, and realized that it's due to the thickness of the wire. You know, in connection, it's not all wires that you can use. Somewhere you can use 2 MA for transformation. So we realized that the wire was the cause. That's why we couldn't demonstrate anything for you to see. Thank you.
Thank you very much, Bosek. Please out. Hello. Okay. All right. So, very quick one, very simple questions, and I also want answers. Okay. So the first one is, what is the total cost of your project? Okay, so do you have that?
2,560. 2,560.
Target markets.
Okay. Please, it's the oddness because you are in OT region, and that place there are a lot of sunlight there. So our target is to reach those people from the north side, because a lot of solar energy is from instead of them befalling disease using it, they will rather use this system to generate to cook their food. And also not only OT region, since it can be used to cook all kind of food, we specify all Africa. To innovate this world, then it can go worldwide.
So we have a lot of rural settings, and then being with the people, I have realized, or what I have seen, I am wondering if you would have a lot of families who will be able to raise that much. Is that a possibility that you could modify the system so that at least your cost would go down in order for, many households to really this technology? Thank you.
There's much possibilities for modifying these things for no cost, but actually we were not having much, or we had a financial constraint. That much of our systems have not been well organized, and as you were saying, there are more possibilities and there are more ways we can modify this thing from easy usage.
Thank you. Thanks very much for the presentation. It's quite an interesting system you guys have put together to be able to convert electrical energy into thermal energy. I have a few questions for you. The first one, since this is a direct current, DC, coming into the heat plugs, how are you able to regulate the amount or the intensity of the heat that comes into the stove? The question.
Yes, sir.
You have connected your heat plug or plugs to the battery.
Yes, sir.
So the energy in question here is coming from the battery. Okay. How are you able to regulate the intensity of the heat that comes into or that gets out of the heat plugs?
Thank you very much for the. Please, in this our setup, we did not add anything to step the heat down. But if they want to improve upon it, they can add a thermostat, so that if in case the heat is too much, the flow of charges will break, then the temperature will cool down.
Did you do this thing by yourself?
Yes, sir. But the welding and things, we send it to the welders so they do it for us. But the plan is from the team.
All right, that's fine. Then the question. You said you need just about 10 minutes to prepare food with this.
Yes, please.
Did you really telling us?
Sir, please, what I meant was, in normal sense, to go to the farm to search for firewood, let's say it's about 25 minutes. But
listen. Did you measure that with the heat plug solar cooker?
Yes, please. We measure it, and I mentioned earlier it was 45 minutes I used to prepare the rice. I mentioned it 10 minutes. It's like an imaginary. So like the time that you go to the farm and search for firewood, let's take it's about 25 minutes. But here you will not work. You just put it on.
This technology should appear at the national stage. Would you want to just be giving us imaginary figures?
No, please.
So please, make sure you have your facts and figures right. Okay?
So please, in addition to what you were saying, in addition, the tips get heated in just a minute. It's very fast. As in, when we connect it, or when we close the circuits, and then we allow the flow of current, it doesn't take much time for the tapes to get heated. So to add what we said earlier, sorry.
No, I agree with you. It's
Yes, sir. Hi. Yes, sir. Okay, sir. Okay, sir.
Very innovative that can easily build. Thank you.
Yes, sir.
Easier to okay. Compare and start cooking. That was what I got from the presentation. Not that it.
No. Sir, it's a DC current.
But type. I want to so if you have a setup like this, of course it will take 45 minutes to cook or whatever, 1 hour. But how long can you use it in a day? For your prototype, for instance, where you have your panel charging the battery, how long can you use it in a day?
Say, depending on the 3 costs.
Runs up, right? And when the energy coming out cooking is more than the input. It could be done any sizing, but I didn't see any sizing you've done though. So how long is it cook a day? Typically, how many hours?
So you can use it for your 3-course meal. The morning, the afternoon, and the evening.
Time.
You have cooked rice. You have cooked rice, sorry. And so it's okay. So but we specifically don't know how many hours it will take us.
And also it depends on the quantity of voltage in the it has stored here.
Maybe a last point. The engineer. Convert electrical energy to thermal energy, so you should be careful when you are presenting. Thank you.
Thank you very much, Busek. You are duly discharged. Shall we please welcome Peje Senior High School?
Been discharged, so you I'll forgive you. Hello. Hello. Okay, hello.
Good afternoon, everybody. This is Peje Senior High School representing Volta Region at the 3rd edition of the SHS Renewable Energy Challenge. Our project is on preservation of fruits and vegetables using solar dehydrator. These are the members of the team: Amuzu Obed, Latte Lawson, Ahiale John Kofi, and myself, Glau Priscilla. Fruits and vegetables are a great source of vitamins, minerals, and fiber. High diet in fruits and vegetables help the body against diseases like cancer, diabetes, and heart diseases. Fruits and vegetables eating go waste before use due to high contents in them. It is estimated that about 20 to 50% of fruits and vegetables damage in storage during transport or in the markets each year. It is therefore needed to exploit this. It is therefore needed to exploit renewable energy sources in preservation of fruits and vegetables. Ghana being endowed with abundant renewable energy sources like solar, wind, and hydro energies, which are clean, have no or less environmental and health impact on us. Fruits and vegetables can be preserved by canning, freezing, and drying. However, the cost of acquiring technologies, energy, environmental, and health impact on energy sources which are on preservation are matters of concern. Examples of energy sources like firewood, fossil fuel, and coal tend to release emissions which pollute the environment, and it is also estimated by World Health Organization cause the death of 4 million people each year.
Looking at the great importance we gain from fruits and vegetables and the amounts that go waste each year, and looking at the clean, available, and abundant renewable energy Ghana is having, our team seek to make use of this renewable energy in the preservation of the fruits and vegetables. The objective of our team is to design an equipment that use renewable energy in the preservation of fruits and vegetables. And the equipment should hygienically enhance the shelf life of the fruits and vegetables without destroying their nutritional value. The equipment should also be made of local materials, and then the equipment should be used for domestic and commercial purposes. In combination of our problem statement and objective, the team considered some points. One, the team identified solar energy as the appropriate, abundant, and clean renewable energy around us. And then the team identified drying as an appropriate way of preserving the fruit and vegetables. With this, we came up with a solar dehydrator. What then is a solar dehydrator? A solar dehydrator is a device that uses heat from the sun to remove moisture from the fruits and vegetables by extending their shelf life and also reducing microbial actions. The materials we use in making this solar dehydrator are common materials. Example is what? A PET bottle is what we use over here, and also a copper tube, solar film, and aluminium sheet, and plywood, also PVC pipes. In the construction of this, we did it by ourselves with the aid of our school technicians.
Okay, this is how the machine works. Air is drawn through the filter dryer. So this is the filter dryer over here. Air is drawn through the filter dryer into the line focus collector. These two things we have here are the line focus collector. The line focus collector. Okay. The filter dryer consists of an activated charcoal which removes moisture from the air, and also consists of filter paper which filters the air. The air then moves into the line focus collector. The line focus collector is lined with an aluminum foil which concentrates all the solar radiations onto the
copper tube or copper tube. So the air inside the copper tube gets heated. When the air gets heated in the copper tube, it then moves into the drying chamber. So this is a drying chamber. Okay. When the air comes to the drying chamber, there is a pump over here which distributes the hot air that enters the chamber evenly to dry the fruits and the vegetables. Okay. So the moist air from the fruits and the vegetables escape through the chimney over here. Okay. The solar panel over here generates direct current from the solar or from the sun. That is DC, direct current, which powers the blower in the drying chamber, and parts of the current used to charge the battery, and that a part of that current is used or is converted into an alternating current by an inverter over here, which powers the pump. This is the pump over here, which powers the pump. So the pump go ahead and circulates the hot water in the system. So that's how the machine functions.
In a 3 hours experiment to try and dehydrate garden egg and okra using the dehydrator and direct sunlight, it has been noted that at the end, it has been noted that the temperature inside the chamber was 42 degrees Celsius and that of outside was 45 degrees Celsius. And also, from the displayed image, it can be noted that after the experiment, the garden egg inside the chamber has preserved their color, their shape, and also their flavor. But the one outside, it could be seen that they have lost their color and also their shape and even their flavor. So it is based on this experiment, it is estimated that for food to be dry inside the dry chamber properly, it needs 2 days with a good sunshine. Now, for every device, there is a limitation and there are ways to improve upon those limitations. For this device, the device can work only during the day. And to improve upon that, there is a need of a thermal storage, which will store heat collection during the day that will be used during the night. And also, our device cannot work effectively during days that the sun is less. So to improve upon that, there is need of use of what? Solar evacuated tube at the place of the absorber tube. So in this case, we will use absorber tube. So when you use the solar evacuated tube, it will make the machine be able to collect the sunlight or to collect the sun heat very effectively. And also with our machine, it requires a lot of monitoring, which means there is need of someone to be there turning the collector for it to face the sun. To improve upon that, there's need of a computerized monitoring and also a control system that will allow the machine to collect heat very efficiently. And last but not the least, it requires a good tracking system. For a tracking system, we all know that the sun is never stationary. So for that reason, there is a need to be tracking the sun. So if the tracking system is very good, that will allow to collect all the sun radiation. Even though if sun will be lost, it will be less, and that will improve upon the working power of the machine. And also for every machine, there are people or target that can use the machine. In this case, the machine can be used in the house. In the house, it will be used to preserve fruit and vegetable for future use. And also, restaurant can use this machine to preserve fruit and vegetable, which will be used in preparation of special dishes. And farmers, they can use this machine to preserve their surplus fruit and vegetable produce, which will be sold at a better price when the demand is high. And in business, this machine can be used to preserve fruit and vegetable to prepare snacks which will be sold in the market. And also, some of the special advantages of this machine is that it improves the availability of fruit and vegetable in the market. This machine also reduces the cost of electricity and fuel bill. And also, the machine emits less or no greenhouse gases in its operation. Thank you. Now on the pump. So on the pump. Check the connection at the end.
Okay. Okay. So you are using electricity.
We are only let's verify something.
Okay. All right. That's all. All right. I can't put an answer. Budget cool. It's interesting.
Never mind now.
Have you also taken this to the field for testing?
No. Since we have used it to dry garden egg and ugu, those are some of the vegetables we use in the house, and also the sun is available in the house, therefore it can be used in the house too.
Before you dry your produce, i.e. vegetable or what have you, did you take the moisture content?
No. But even fruit and vegetable, we all know that there are some of the vegetables such as tomato that contain air, and there are some that contain a low moisture content such as okra.
We don't know. Maybe no. I'm going to ask a follow-up question, but after drying your produce, did you also take the moisture content of the final product?
Yes, the moisture content of the first or the fruit. It was more than the moisture of when we dried it. Yes.
What is moisture?
So the moisture content is the amount of water contained in the food. And in this case, when we cut the fruit and vegetable at the beginning, it could be seen that they are shaped and none of their part was shrunk. But at the end of the experiment, it could be seen that although the form or the shape did not change, part of the vegetable has been shrunk, which means there's a loss of water.
We cannot, a clear objective of what we are doing. Yes, it's a very nice device, buying solar electricity and solar thermal to process food. And there's no doubt that if we get this right, it can be deployed in many areas. But for you, these are some of the basic things that we expect to hear from you. By introducing thing, you can reduce the moisture content from 35% to that low. We need to have that information from. If you've not done it, I will encourage you to begin to look at it if you have the chance to present this at the national level. You talked about the uniformity of drugs. In terms of marketability, how can you explain that?
Okay, in terms of marketability, let's say you want to use maybe mango to prepare some snacks, dried mango for some snacks. When, assuming you buy a snack and the product inside look different, everyone and its color, its shape and all that, you wouldn't like it. So for the uniformity of the color, the shape and everything, it is very good when you use those fruits and vegetables for snacks. And it will also be attractive.
Yeah, very much. And a normal solar dryer. What's the difference between this one and a normal solar dryer?
Use a parabolic. The solar dryer do not use a parabolic trough or a line focus collector. But with this one, we have the solar panel and at the parabolic trough or a line focus collector, which converts all radiation onto the tube. So even once you have the parabolic trough collector, you can still make use of your sun radiation.
I don't know what's the synergy between the PV panel and then the thermal system. What does this do and what does that do?
The solar panel, okay. The solar panel generates direct current. Yes, from the sunlight.
What does it do here?
So it gives power to the blower and the pump. That is the pump over there.
Oh, okay, so the blower
and the pump. But this collect over there, the sun is being reflected, concentrated on the pipes, so that light can get heated.
Okay. On to the next thing. I think it's best if the outer cup of the dryer is made of perspex. Normal solar dryers are perspex material. You can see through. If you can have one instead of the wooden structure, the additional heat, with additional thermal and sun, because perspex heat the internal of your dryer.
Okay, sir.
And then you have your additional, so from the one directly perspex material instead of wood.
Some of the improvements we are working.
So yeah, so you would improve the internal heat of the.
Okay, sir. And okay, the four is to prevent heat loss by radiation. That's the four inside, and to prevent dampings of the wood. Oh, I was just giving you a briefing. Thank you very much. I was thinking and the maximum period was 2 days. So I wanted to verify, give you that kind of result, because it looks, from my understanding, it looks like period for.
As for the vegetable side, you use the garden egg and the okra. For the fruit side, you use the mango. This is why we are still, so that it will be point of our evidence.
So each of them used.
That is one not and you this.
Okay, so I just want to verify something. Does it mean if as well 2 days?
For no rest of the cassava is for it to take a long time than the.
Okay, but you are here to check on that, right?
Yes.
Okay, so these are some of the specifics we are talking about. Tell us specifically that when we use for this particular range of materials, in order to do this, it helps going to think about that. All right. It's very simple. Tell me specific are the... Yes.
I am the one that feeds the aluminum, the solar film inside the reflectors, and also I'm responsible for the aluminum film inside the chamber and on the trays.
Okay. I was the one that took the accurate dimensions of the roots and all the dimensions. I was responsible.
As a home economics student, I bring the idea of drying of the fruits and vegetables so that they will not lose their nutrients.
The painting, actually, I neutralized white and black. So I mix black and white. Black absorbs heat and white reflects heat. So when you both of them, they try. That's why we use ash.
You know, a fabric.
Said the thing was assembled in their workshop. That was mentioned in their presentation.
Please, for the putting up, we are not technicians too, so we seek the attention of the school's carpenter to do some nailing and cutting and others for us.
I wanted to, sorry. Engineer Ted mentioned how do you measure the moisture. I wanted to suggest to the school that you get a moisture meter, one for fruits. I'm sure you can get some in Ghana, right? So that at least it's an easy way. It's a way to at least get an approximate moisture content of the starting material and then of the one at the end of the process.
We are grateful, sir.
Maybe yes. Difference will give you that same measure.
We are grateful, sir.
All right, so with that, you are duly discharged. Shall we please put an answer for them? So that whilst Peja leaves stage, let us also welcome Ya Asantoa girls.
Hello.
Hello.
Hey, your pointer.
So the thing is, harnessing solar energy for clean cooking using PCM electric cooker. Good day, ladies and gentlemen. I go by the name Emanuela Amininyako and with my colleagues Elizabeth, Kekeli, and Esther, Renewable Energy Team from Yasanta Girls Senior High School. This is our presentation outline. Before we proceed with our presentation, we want to pose this question to the audience. Who can take in rice or meat without cooking? Since we are CMOs, it means we all cook our food before we take it in. Cooking is essential and energy is needed to do that. Our existing technologies make use of the burning of hydrocarbons and fossil fuel as a source for cooking. Even in our rural areas, most of them make use of firewood as a source of fuel for cooking. According to the SIT assessment report of IPCC 2021, the burning of hydrocarbon fuels and firewood contribute to climate change and its related issues. ITAL 2021 also states that all these contribute to global warming. I'm sure you all would not say that in a stress region like Ghana, there is a need for us to revert to the source of cooking. In high school, a PCM-based photoelectric cooker. Photo because it makes use of solar energy, and then electric because the solar energy is converted into electrical energy. Our main objective is to put forward the concept of cooking. That is why we specifically designed this technology to address developmental challenges. That is the goal 7, which is and then to design an environmentally friendly cooking device that of climate action, and finally to eliminate negative health impact on women and children. That is the goal of good health.
For our components, we have our solar panel, a heating element, isolating material, a PCM, that's our phase change material, and then our cooking chamber.
Isolating material, we chose cotton because cotton is readily available and has a low thermal conductivity. Our solar panel, which changes the energy into electrical energy, gives an output voltage of 34.4 volts and a power rating of 345 watts. Our heating core, which changes the electrical energy into heat energy, is made of nichrome wire. We can see from the screen that our heating core is placed on a ceramic to avoid short circuiting.
Our next and key component is our PCM. I'm sure when my colleagues mentioned phase change material, we are all wondering what the substance is. A PCM is just any substance that is able to absorb and store energy during heating as it changes its state, and then later as it cools down, it is able to release the stored heat. The example of PCMs are including our local coconut oil, paraffin wax, our common throttle. But for our project, we chose a throttle because it has a high melting point and figure A shows from a discarded rice cooker. Figure B is a piece which has a throttle, a heating element, and from B constitutes our whole cooking chamber.
Looking at our schematic diagram, we can see that as the sun rays falls in the solar panel, the solar energy is being changed to electrical energy. This electrical energy passes through our conducting wire and gets to our heating element. The electrical energy is then changed to heat. This heat energy is being supplied to our cooking space and the PCM. So concurrently, as food is being cooked, energy is being stored in the PCM.
For our assembly section, we have our PCM holder, as my colleague is demonstrating. We then fix our heating element in it and pour our PCM. We fix our inner cooking chamber and insulate the whole device in order to prevent its loss by radiation and conduction. We then fix our outer cooking chamber. We also attach a thermostat in order to regulate the heat supplied to our cooking chamber. And with this, our device is made complete. I know that some of you will be thinking that to use a normal rice cooker, but a normal rice cooker uses an AC, whilst our solar panel produces a DC. So this means we cannot connect our solar panel to our normal rice cooker. Therefore, we designed our own heating element, which works on the principle that as current is persistent wire, heat is produced. For our system design, we have the power of our heating element, that's our nichrome wire, to be 192 watts.
During our boiling test, a graph of temperature was plotted against time, and the least temperature recorded was 30 degrees Celsius, and the highest was 100 degrees Celsius, within of about 1 hour. So for the practicality, we tried cooking with a device, that is our PCM-based photoelectric cooker. We tried the cooking method and the frying method. The frying method, we tried shallow frying and the deep frying. So this is the deep frying method, of which we were able to fry ripe plantain. And then for the cooking method, we were able to cook rice with 320 cm of water. Yes, that's the PCM-based photoelectric cooker. And then the shallow frying. Yes, that's the shallow frying. We're able to fry an egg. Yes, PCM-based photoelectric cooker for you. And for this one, we were able to cook our very own Indomie with a PCM-based photoelectric cooker. As you can see, that's the vapor coming out of it. Wow. Yes. Okay.
For our environmental impacts, our device poses no threat to the environment, since there is no emission of greenhouse gases.
Okay, we are all talking of clean energy and clean cooking. Well, I think clean cooking should be done in a clean environment. That is why we talk of recycling. Recycling because our technology is made of a discarded rice cooker. It is waste management, it's not biodegradable.
Socioeconomically, our is cost effective, since in the long run, the cost of using our technology compared to the cost of using other sources of fuel like LPG for cooking is relatively minimal.
Finally, looking at our insulating marketing, because cotton is locally grown in Ghana here, and we favor the local growers of cotton, considering our of aluminium, and also favor local production of the aluminium. The innovative part of our project is how we are able to store solar energy in the form of heat energy in the PCM, which is the phase change material. We choose the PCM because we want to cut down costs when we use the storage batteries, and then for stability during fluctuations in the sun's intensity.
Sure, some of us are wondering which group of people are going to be using this technology. Well, our devices in urban and peri-urban areas due to the high cost of the solar panels. However, this should not discourage the implementation of our project, since in the long run it is cost effective. So for in building our technology, our 2 solar panels, each of power rating 245 watts, cost 200 Ghana cedis. Our 10mm cable costs 175 cedis. Our PCM, which weighs 100 Ghana cedis, with 1 kilogram costs 100 Ghana cedis, and our cotton costs 30 cedis. So in total, our product costs 305 Ghana cedis.
The graph on the screen represents the cost-benefit analysis of energy cooking mechanisms, and this is a research conducted by Opoku et al. 2022. As you can see from the graph, the red represents the use of charcoal for cooking, the green represents the use of solar-based device for cooking, and the gray represents the use of grid electricity for cooking. From our graph, the initial cost using our solar-based device is higher as compared to the use of the charcoal and the grid electricity. But as we can see from the graph, as time goes on, the use of the solar-based remains relatively stable, but the use of the charcoal and the grid electricity increases.
This is a presentation by high school representing the Ashanti region. Thank you.
Thank you very much, Central girls, for that wonderful and brilliant performance. I want to find out this quickly from you. The first one is how easy is it to get your material? Because you are how easy
PCM material.
Yes. How available is it? I mean, the very kind that you use. Yes.
The PCM available in East Legon. So if you want the PCM, you can order from
which means so far in Ghana, if you are looking for this,
that's a car. You can get a car.
okay, but apart from Accra, you're not looking out for others. Okay, so now has to do with this. How easy?
Okay, you can also use aluminum containers for your project too. But just to we decided to use so you can also of these substances.
Very good, because when we are thinking of the large, then we are not going to.
Thank you.
If you wondering, environment, why?
Please, we said clean cooking in a clean environment because if you are to cook in a dirty environment, I'm sure you are going to contract certain diseases. That is why from our objectives, we talk of the good health and human well-being. That is the SDG Goal 3, which talks of good health and human well-being. So yes.
See the clean cooking, but
okay, for this one, it's not biodegradable. That is why it's clean cooking in a clean environment. Since the discarded rice cooker, it's not biodegradable.
What is the total wattage or power requirement or this device?
The heating element requires a power rating of 192 watts.
192 watts. That's how much power you need.
Please.
Are you sure about that?
Yes, from the 192 watts.
In your cost estimate, I noticed that the nameplate capacity for your panel is over 300 watts. If you need 192 watts, why do you go in for such a big panel?
It has a power 45 watts. It was connected in parallel heating with it again was 31 volts when the load was applied. So after calculated for the power by multiplying the current by the time
Can you go over that? Can you go over that again?
Okay. Our solar a power rating of 345 watts, but its output voltage is 34.4. So when we connected the load, the voltage dropped to 31 volts. So in parallel to our heating element, and therefore the voltage is the same. In calculating for the power of the heating element, we multiply the voltage by the current, and that's why you have the 192 watts.
Thank you very much for that brilliant explanation. My last question. variability of the solar resource. Variability of the solar resource. How are you able to address that? If we want to scale up this, how do you address the issue of?
Okay, so as we said, the PCM is for stability during power fluctuations. During fluctuations in the sun intensity. So we use the PCM to, apply constant heat to our cooking chamber. So that's it. So it caters for the fluctuations of the sun's intensity. All right.
Just two questions. So, number one, can you use at night?
Yes. You can use it in the night because it's acting as a storage battery. The PCM is able to change its state from the solid state into the molten state. At this state, it stores energy. So in the night, when there is no sunlight, the PCM gives off the heat to cook them.
Seriously, for how long? For how long is it stored?
Okay, it depends on the kind of food you are cooking and for how long. We've not researched about that.
Are you confident about saying that?
Yes, because we use the PCM to cook in
that small thing. Anyway, last one. Estimation. PCM 1 kilogram for 100 Ghana cedi. Do you use a 1 kilogram for each stove? Like, do you use all of it per stove? How much PCM by weight do you use per stove?
Okay, so for our projects, because we're trying to test it, we use the whole 1 kilogram for it. Yeah, it worked.
More or less for.
Well, we think the storage of the heat inside the PCM also depends on the amount, because the greater the amount of PCM you have in your device, the greater the amount of heat it can store for you.
Did not test to be sure of how much exactly you need for. I mean, if you are designing this and selling, you should be able to tell the user that use 1 kilogram or 2 kilogram. You haven't done any tests like that.
Well, no, but for our project, we use 1 kg, so that's how we did it. So right now, we are
Thank you very much, and you are duly discharged. Shall we please give it up for them whilst we equally invite St. Joseph. St. Joseph Senior High, the stage is duly yours.
rising cost of gas for domestic cooking affecting students in the home economic department. In my school, for example, students in the home economic department had to gather funds for their practicals, which most students are unable to give out their funds. But with the use of this simple solar oven, that issue has been resolved in my school.
Again, the rising cost of domestic fuel affecting the national economy. The national economy as a whole is faced with this challenge. As we hear of the rapid increase in fuel prices, not everyone can afford. So we came out with this project to help solve this problem. As scientists, we went through some stages. We call these the foundation stage, developing stage, and the final stage. My colleagues here will help enlighten us more. At the foundation stage, my team members and I went through two major activities. The first of it is the selection of materials, where we went around in our school to determine the materials to be used for the project. The second of these activities is the collection of these local materials, which we determined to be suitable for our project here. And here are some materials which we use. The first of it is the styrofoam, aluminum foil, and many more. Now we are at the developing stage. This is where we talk about how the materials were used and their purpose, which it is serving in the project. My colleagues will help enlighten us. I'm going to talk about the styrofoam and the aluminum foil. So, our project here is a 4-layer system, where the first layer is made of aluminum foil, which helps to reflect the sun's rays within the chamber. The second is an aluminum sheet, which helps to conduct the heat energy within the chamber, which is accumulated here. The third layer is a wooden slab, which gives the chamber its firm and rigid shape. And the fourth is the styrofoam, which acts as an insulating material, which helps to retain the heat accumulated within the chamber, and also acts as an insulating material. Another material used is the mirror. Why the mirror? The mirror was used because it's a good reflecting material. Also, the mirror was positioned this way to allow the passage of sun rays onto the surface of the chamber and also onto the mirror, which reflects it into the chamber. The mirror also serves as a barrier which refocuses escaping heat from the chamber back into the chamber. So with this, there's a continuous cycle of heat to and from the chamber.
As part of our project, it's a thermometer which is held in position by the cork, which prevents excess heat loss. This thermometer was used to determine the temperature within our oven, and also the temperature at which different types of dishes were being prepared. We also have within our oven this black saucepan with the plain lid. We chose black because black is a good absorber of heat, and also the plain lid as we have in our rice cookers to observe our dishes being prepared. When this black saucepan is being placed within the oven, it absorbs all the reflecting rays by the aluminum foil to gain heat to prepare our dishes.
Now we are at the final stage. This is where we did the application of stickers and the determination of cost. This sticker here is beautifying our project, and it's also telling us that it's a product of St. Joseph Senior High School. Also, there is a food sticker over here, which is also giving us the impression that it's indeed a food cooking material. In determining the cost, the collection of materials all summed up to 100 Ghana cedis, and we intend to sell our project for a cool price of 150 Ghana cedis. 150 Ghana cedis because the 25 cedis mirror you buy today wouldn't be the same tomorrow due to the rate of inflation these days. So, right now, our project here has a target market. Generally, it's for domestic purposes, but specifically, we are targeting students due to its low cost or its low selling price. And also, secondly, we are targeting farmers. Farmers because our system here produces low smoke, and it also does not need it doesn't need fire to work, whereas our farmers work on the farm, and this will also prevent bushfires.
Technology technology behind our project. The technology behind our project is the thermoflask technology, which is based on the law of conservation of heat energy. The energy accumulated within this oven was being conserved as we have in the thermoflask. These are examples of food dishes we prepared using our oven. That's the pancake and also the egg. We also use cooking methods such as the grilling and that of stewing to
Our project will impact in our life socially by creating jobs. A craftsman can learn how to make this simple solar oven. Go out there, create an avenue, and then employ the youth especially. Train them to make it, and they can also do them on their own and sell for their own income. In a way, decreasing unemployment in the country. It has environmental impact on our life where it prevents air pollution, land pollution, and make good use of our waste materials. Strength of our project. Our project is cheaper and easy to use. That is, it does not require fuel. It's also environmentally friendly because it's a no-smoke producer.
Limitations of our project. As first timers, our project will definitely have some deficits, and our project cannot be used when the sun is not out. This is especially during the rainy season where the sunshine is not experienced.
Improvements. In the future, we intend to improve on our project by the use of solar panels and modems to absorb and store the excess energy. Also, the use of the thermostat to regulate temperatures. Here are some pictures to show our development. The styrofoam being put together and the aluminum sheets lying in it. At this point, we introduce ourselves. We have in our midst our facilitator, who is in the person of Mr. Seth Ojo Kwate and Ms. Isabella Abeble,
Ms. Dorcas Tete, and
Ms. Evelyn Luchu. And I'm in the person of Josephine Edu. Together, we present to you a simple solar oven. Thank you. We can boil egg with it. Also, we can cook pancake and some vegetables.
So you can do proper food.
You can cook.
The way you start egg and then pancake and vegetables, it sounded like do proper food with it.
Okay.
But
we do shallow frying.
Yes, but how would you do the control? You have it.
We put the oil inside and then we break our egg inside. You can. When it's for eggs, we take the lid off so we can
affect the temperature inside.
Before we do cooking, we take it off, do everything, and then we cover it without the lid on the cooking pot.
So does it mean each time remove the, and then is that how we?
Okay, so we cover the oven to make the oil become hot. So when the oil becomes hot, we take off everything and then we start our frying. We have the aluminum foil, and also our saucepan is black. So with the help of the aluminum foil and then there's a black saucepan, the heat is being trapped by the saucepan within the oven. Yes, please.
Okay. Actually, we are cooking. Coming out when you're cooking rice. It's covered. how does the vapor escape? I mean, let's say you're eating cooking yam. There's some vapor that leaves. How does it escape from your cooking pot?
So when cooking rice, we need everything in there for the better cooking. So when all these vapors are also needed in the cooking. So with the glass, we are preventing them from rather escaping. And then having a lid. So in case you want the vapor, just shift the lid in, and then this one will also serve as and then the vapor will be in the chamber, but the food is Personally, when we were cooking the rice, it didn't see any much challenge with it.
Joseph, an interesting presentation, an interesting concept. On a light note, what is the relationship between the color of your oven and your uniform?
We wanted to make it, because it's our school, we decided to use the color to beautify it.
Okay, interesting. So, the dimension of the box, what is the relationship between the and the energy that you can in the cooking vessel?
Okay, for the egg, we were able to. For the dimension,
the size of the box.
This side.
I don't know. Like a pound, right? Is that correct? It has leg, width, and height. Is that correct? The relationship, the size of this box and the amount of it.
Okay. The size of this box actually is given, we use an insulating material, the styrofoam. All the bulky parts you see here is made of the styrofoam. And then you have the chamber inside. So it is, in a way, maintaining the heat accumulated in the chamber over here. Yes, please. Yes, please. Yes, please.
Thinking of improving on this by bringing in thermal controllers, solar panels to energy what's not available. Have you considered the impact of this improvement on costs?
Yes, please. Okay, it depends on the size we'll create for that new oven. This oven like this will need a solar panel which will cost 500 cedis on the market. And then if it is lesser, it will take a much lesser solar panel to power it.
About your project? What?
Okay, so project here prevents burns as compared to the normal ways of cooking in our homes and schools. Yes. And when using it, you wouldn't get any burns at using or during the period of its usage. But as compared to our gas and then our charcoals and stuff, they can hurt us or we can get burnt upon touching them or something when something happens.
Any of the answer she has provided.
And also,
in terms of technology, what is so innovative about what we are witnessing?
okay. It's the use of the local materials in making this project, and also we applying the question in here.
All right, so thank you very much.
I want to see you looking so free and more cheerful just as you were doing your presentation. Let me see the smiles. So I have just two very simple questions, not deep ones. So very simple explanation, all right? I want to find out what has been the maximum temperature you have ever recorded in the system? See? And I also wanted to find this out. You said you prepared some stew when you were giving the examples. Or you didn't prepare the stew. Maybe I didn't hear you well. Vegetable stew or steam? Yes, so steam, right? What vegetables?
Is it froyer and now?
Yes, she's talking about froyer. Or?
Steaming.
Please, I want to hear it from you. You did it. So exactly what you are saying.
We did a vegetable stew.
Yes, so with our normal tomato stew, you added some cabbages and some other meat. I want to know specifically the one you did.
We grind tomatoes and then pepper outside and in the little then let pure outside.
I wanted to make it very simple. That's tomato stew.
Yes, please.
That I'll know that no, it wasn't kontomire, it wasn't okra, that sort of thing. Okay, good. So I wanted to verify how long it took you to prepare that, because you realize Prof asked you what exactly you were doing in terms of frying the egg. So any time you want to turn, you need to open. Good. So I wanted to verify what exactly you did when you were preparing the stew. How long it took you. I'm interested in that.
Yeah, onwards. We added and pepper. Day it was able to cooked. It was 28. Because degrees Celsius to it. There. Degrees Celsius. It's there.
I think you are not getting what I wanted to verify. How long?
Okay, that's fine. It took 28 minutes, sir.
To be sure of that. 28 minutes. I missed opening and closing. How many times did you open it within that period?
Well, because the system is made, it had to be opened that much. So, place the ground tomatoes in there. And time we open the system.
So once we place the grinded tomatoes in there, we covered it, and after the vegetables started cooking before we added the grinded tomatoes. That was around 20 minutes, and then when we added the grinded tomatoes and covered it, it lasted for 28 minutes, and it was cooked.
I am.
So you said?
Temperature.
Yes, please. Then that was when it was 94 degrees Celsius, the highest temperature.
I see. I prefer you should have videos of all right? It helps so that whoever wants to track your business help you. All right. Thank you all for me, and then we are very grateful. You are duly discharged. Shall we please welcome Presbyterian Boys Senior High School.
Thank you very much. Wait for Presby. As we wait for Presec, I want to see all our students, regional coordinators, and teachers seated right now. All those outside, can we come in and be seated? I can see Fantiman girls set. Megis, you are not set. I want to see all students, coordinators, teachers seated right now. Thank you very much. So call your colleagues. This is the last school, and we want to be as quick as possible. Thank you very much.
Yes. Okay, so today I'm here to present our project, which is called the Portable Solar Dryer, which has been made from waste cans. So I am David Chuniba Akodia, assisted by
Fidox Maja,
Melvin Kaladere,
Dorothy Benedict's party.
Okay, now to our problem statement. Now, post-harvest losses is not a problem which came. For instance, from the Voices newsletter, which was taken in 2006, we found out that 25% of all the cereals which are harvested in Ghana are lost to post-harvest losses. Also, taking an average annually, 318,540 tons of all the maize which is made in Ghana also goes off. That's making a total of 18% of the total maize which is cultivated in Ghana. From what we just heard, we can clearly know that the post-harvest losses is a nightmare to our peasant farmers. And as a result of this, in accordance with the theme of this competition, clean cooking and food processing using renewable energy technologies, we came up with a portable, easily reproducible and cost-effective units so as to help Ghana unravel its agricultural issues on post-harvest losses. Now, I'd like to talk about the objectives of this project. Now, in seeking to eradicate post-harvest losses, the project seeks to, the first one being, we want this project to be an innovative food processing unit that also takes into account environmental sustainability issues. Also, we want this project to be a project that will be able to use a lesser area of operation. For instance, from what we know from the traditional method, before you can use it, you have to clear a large area of land for the same given amount of agricultural produce. So we want our project to be able to use a lesser area for that. The third one being, we want this project to be a hygienic unit that will prevent insects, birds, dust, and other challenges which are faced in the traditional method, that's normally on palm fronds, rafters, and the bare floor. The fourth objective of our project is that we want it to take a shorter drying period. And the last objective for our project is that we want it to be a portable, cost-effective, and easily producible unit that can be used for both domestic and large-scale units. So I hand it over to my brother Fedox to continue with the construction.
So for the construction, first of all, we made a sketch of our solar dryer, and we did an orthographic projection of our solar dryer. That is, we drew a two-dimensional structure of this 3D structure. So this is the orthographic projection of our solar dryer. So our solar dryer is made up of two main parts. That is the place for keeping the solar collectors and the drying chamber. Now the dimension for this solar dryer is 170 centimeters by 89 centimeters by 156 centimeters. That's for the whole solar dryer. Then the drying chamber is 170 centimeters by 89 centimeters by 120 centimeters. Yes. So this system incorporates two methods of heating. That is the direct heating method and the indirect heating method. For the direct heating method, now this roofing sheet, we constructed this roofing sheet. This roofing sheet is actually transparent, so it allows radiant heat from the sun to pass through it to heat the food substance in the drying chamber. So that's for the direct heating. Now for the indirect heating, we used the concept of convection. So our system doesn't only just use solar energy, but also uses wind energy, which makes our system very powerful. Now, first of all, we took waste cans from the environment. Then we constructed a wooden structure or a wooden frame, and we lined we took the cans and cut the sides of the cans, and we aligned them orderly or linearly on the wooden frame, and we painted them black. Then we had a perspex panel which is transparent, and we put it on the solar collector. So what happens is that because it is painted black, it actually absorbs heat and wind from the outside environment to pass through heat and get heated by the absorbed heat and move into the system. Yes. Then we also have the Velcro netting. Now, because we want to ensure the hygienic system of our food, we use the Velcro netting to prevent the entry of dust and also to prevent the entry of insects. Then we also have handles for our solar dryer. And inside of the drying system is aluminum sheet which has been lined. Because it is actually shiny, it actually helps in the reflection of light onto the food substance. And the ties also help in the easy movement of our solar dryer. Now, we took certain precautions. We made sure that the cans are painted totally black to absorb maximum amount of heat. Then also, we made sure that the nails and screws are tightly fixed onto our system to ensure that our system is very robust. Then also for the sockets, the socket helps in the packing of our solar collectors back into the system. Yes. Then for the scientific principles, conduction through the solar collectors, because they are aligned to each other, there is conduction. Then convection through heat flow as it passes through the indirect method. Then evaporation. So the ventilation hose helps in the exit of water vapor because drying has to do with evaporation.
Yes, so I may ask, who exactly is the project for? Well, our target market includes farmers, agro-processors, fishmongers, and even a normal individual who is interested in food preservation. And also, talking about the uses, it's used for drying foodstuffs such as tilapia, okra, pepper, cassava, and cocoa beans. And we have a short illustration on how we dry the cocoa beans. Okay, moving on. We also use this device to dry medicinal products such as the moringa, which we commonly know as moringa, with scientific name Moringa oleifera. This is used in the treatment of inflammation, and also it's an antioxidant and is used for treatment of diabetes and asthma. We also dried the devil's backbone, what you know as Insuroja, with scientific name Cissus quadrangularis, which is used in the treatment of diabetes, obesity, bone fracture, allergies, etc. Now you might ask, what advantage does this have over the normal drying? Well, it takes a shorter drying period for the foods here, as you can see, and it also can be used to store food after drying it. And this is because we use two methods of heating, as a mixed heating, to dry the food substances. And it also requires less area for drying, because this is a small, it's not that big that you have to clear a large area to be used. And it also protects the food from rain, birds, insects, and other things, because it maintains the quality and quantity of the food. Now to the social impact. It provides employment to constructors, the tailors, the carpenters, and etc., who helped in construction of this thing, and it saves space, time, and labor needed to dry outside, as this one doesn't require large time for it to dry, and also produces hygienic food because the food is protected from those organisms. And on the environment, we used waste cans, which is reducing pollution, and this does not also pollute the environment because the energy produced is clean energy, and it's also helps in curbing land degradation because you don't have to clear land area. And for the disadvantages, you can't use it on rainy days because it depends on the sun, and it also depends on wind flow. So if wind flow is against the one we need, we can't use it. The way out is we are thinking of using incandescent bulbs to power during those times. And on to my brother.
Okay, for the experimental data we used cassava, we used cayenne pepper, we used freshly shelled maize grains. And from the graphs, from the table you see that the masses at the beginning are equal, because of that's how we wanted it. And as you see for the cassava, you see that at the end the mass of the sample within the portable solar dryer was lesser than the mass outside, which shows that more moisture was taken up by the solar dryer than the substance outside. But for the cayenne pepper and the freshly shelled maize grains, you see that the mass outside was smaller than the mass inside, which shows that which would make you think that it doesn't really work well, but it proves the fact that drying it outside would reduce the quality and quantity of the food by attack from pests. So this is the graph presentation. We also dried cocoa, which took a longer time because of unfavorable weather conditions. So, and in the cayenne pepper, we also found maggots growing within it, which shows that indeed drying it outside proves unhygienic to the user. Thank you very much.
Thank you very much for the combine the various renewable energy resources to achieve one goal. The goal is to process food, and you are using the sun. You are using the sun, and you're also using the wind to do that. You talk about the limitation of this device. Do you have in mind a solution to that limit?
Okay, so if the individual would like to dry, say maybe during the rainy season or in the evening, we plan that as part of this improvement, we would get a solar panel which will power incandescent bulbs. We know that incandescent bulbs are able to provide heat. So maybe during this situations where the sun is not there, the incandescent bulbs can rather dry the agricultural produce.
But the solar also has the same limitation. It's not evening and you want to dry in the evening or on a bad weather day, how do you address that limitation?
That's what I was saying, that say we want to dry maybe in the evening, then if this project is accepted and is proved upon, there will be an addition of incandescent bulbs that the individual can use, which has been powered by a solar panel, so as to provide heat like during these situations.
Can you explain to us how solar panel powers an incandescent lamp?
So an incandescent lamp obviously is an electrical tool. So the solar panel will provide electricity to power the incandescent lamp in the night to dry the food within.
Are you sure what you are saying?
Yes, please.
The solar panel.
Okay, so let me rephrase myself. I meant the solar panel would store some of the charges and then it would power the incandescent bulb when there is no sunlight.
How can how can you use
Please, there's a system on the solar, like you're having solar panels, okay, and inside the solar certain devices, the sunlight. About here, sir, I think we're talking about solar battery to store the energy so that when there's no sunlight, maybe during the rainy days, you can use that energy can be dissipated to power the incandescent bulbs that we're talking about.
Batteries to store the energy. That's accurate, that's correct. You brought your photographic drawing and then you told us a few minutes ago that the dimension of that. On the drawing, there is nothing to substantiate that. Can you explain? The dimension? Yes.
Okay, so this is based on the basic information received from GSS. Now,
hold on. Basic information received from where?
Pre-technical skills in GSS. Now, in the drawing of okay, so from the we have. Normally, the dimensions are not added on the drawing as that point. At least that's what we knew.
Sir, please, we talk, for example, 170 centimeters. We actually use the scale to draw the whole structure.
You use a scale?
Yes, please.
Do you have the scale on it?
No, please.
So, Presec, you talk about wind energy, the use of wind energy to also aid in the dry process of the food. Have you measured, or do you have an idea, the minimum wind speed that is required to commence in your chamber?
We've not had an experimental data on that yet. Yeah, on the wind.
So how do you know the wind can dry your produce? How do you know?
Okay, the principle of displacement of air. Actually, we used the concept of convection. So, because the solar collectors are painted black and they absorb heat, when wind passes through it, actually heats the wind and it sends it into the drying chamber to heat the food substance inside.
All right. So another question for you. What would operate this device?
Please, can you come again? Okay, so we need a sunny day and also favorable direction of the wind flow.
You've not done that.
Please.
You've not done any measurement.
We've done.
So if somebody asks what the outside, because working on thermodynamic principle, you're using temperature.
What we did is we measured the amount of moisture which was reduced by first checking the ambient temperature, then checking the corresponding temperature inside the dryer. Then using that, we measured the masses of the control experiment and that of the actual produce which we are going to use. Then we saw that the one inside was drying faster and better than the one outside. Yeah.
Anyway, you brought some where did you do the drying? The cocoa beans, where?
Okay, so we used two samples, one as a control experiment and one as the actual sample. So we just put the samples in, we put outside and inside. Okay, so the one presented today was dried inside the dryer.
Okay, I have to do some further works on it because we should accept this at national level. Some of the questions we would want to get answers to. Humidity in Accra is not the same as humidity in the cocoa growing areas. Therefore, maybe if you subject this device to real life, use, you might have a lot of challenges. To be good for you to do all these measurements and be convinced that ambient conditions, those inside, it will be like this. Thank you.
Yeah, thank you very much, Prosek, and thank you, Engineer Seth. I was quite excited when I saw your device, but as you had the questions, I'm wondering if you did this thing yourself.
Okay, so the overall plan of the dryer came by me. Then they all contributed in the aesthetics that you see now. But with regard to the joining of the parts, we were assisted by a school carpenter to fit in some of the parts.
Because you are unable to answer a lot of the basic questions on it. So
no, sir. Yes, sir.
Well, I'm wondering, what would these frames you have? What would
this? Yes. Okay, so this perspex or acrylic glass, and we use this because with regard to this, comparing this to normal glass would break easier. This one is like less brittle, and also since it's a radiant, and therefore we'll be able to convert all the wavelengths of light on it. So that's why we used the perspex.
And earlier you were talking about storing when we then you went to batteries, but in any case, natural drying is done during the day, let's face it, except we have an electric dryer which dries in the day. There's nothing wrong with it. Just admit that it only dries in the day. But converting power from a battery to heat, that's not a very efficient use of power. I mean, the thing must have some limitation. It's okay that it's a limitation. Okay. And I thought this could do with a blower. If you have a blower somewhere at the bottom that could blow the heat, maybe circulate it, inside, and then the moist air could exit. For this small one, not a few watts with a small solar panel can do that trick for you without bringing in any grid electricity. So that's something you could incorporate. And you could also have, again, ambient conditions. You could have, there are small thermometer temperature sensors on the market, very tiny ones. You can have some, place them around so you can measure the ambient temperature. 1 or 2 outside is fine. Then inside you can have a few on the different racks at the different levels. So you can even develop a temperature profile from morning to evening. You can be able to tell what the temperatures are outside and inside on the first rack, second rack, third rack, in the course of the day.
Yeah, so we actually had that on our table with regard to the experimental data. Yeah.
Yourself, because if you did,
okay, sir.
I like the work, but from the way you're answering the questions now, I'm.
Thank you very much.
Anyway, Pusek,
yes, sir.
Brilliant presentation. You did very well. Listen to you. Have you called? You also heard exactly what you have. Very much, and you are.
Hello. Oh, let's clap for that. Very nice presentation. You can see very talent being there. Thank you for your bit. From where I am coming from, I noted that some two challenges which I would want to address because of examination. Presentations, black converting sunlight to thermal energy. Black converting sunlight to thermal energy. In actual fact, black doesn't convert sunlight to energy of heat and can take. So you take note of that. I wouldn't want to be specific which school said that, but it is a general information to all of us. Then also, in another presentation, I heard transfer of heat through vacuum. We were pointing in the air, transfer of heat through a vacuum. Then I asked myself whether the space here is the vacuum. So we should know what a vacuum is, so that when maybe you are given the opportunity to present your project at the national level, then you know the right term to use when it gets to maybe the explanations of those concepts. Now, because the projects that you presented, I didn't see any of them displayed in a vacuum. They were all displayed here. Okay. I think these are the two concept challenges that I identify. I will call upon Mr. Julius Nkansa to come and take over.
Thank you very much, Mr. Bauer. Here are you comments that I would want to share. Before that, did you miss me? You miss me, eh? I think most of the questions our judges asked you had asked most of you these same questions. Or, you see, so I gave you a poll at the regional level. I give you all the apple. So this is just a reminder to all the schools that whatever happened here today, go back and think and reflect. Hello? Because when it comes to the finals, it's likely you will hear, if not same, similar questions. So take note. All the suggestions, the comments that the judges have made, even if they are not the same judges who will be at the finals, it will surprise you that the same questions or similar questions will be asked. And that one to be Apple 2.0. But don't expect any Apple from me or Wasi, because that one I don't know. Okay. So, I've talked about taking note of the specific questions. So for your project, they ask specific questions. Take note of them. Some suggestions were made regarding if there are some modification improvements that you can make. Take note of them and work on them. I must say that with the 3 best projects that we will find or we will get today, we, the Energy Commission, together with our partners, it was mentioned by the Executive Secretary's speech, with CSIR and then the Clean Cooking Alliance. We are going to provide technical support to all the projects. So identify your modifications. We would work with you to improve upon it. What I want to say is that we will not come and tell you what to do. That one we won't tell you. You have to identify what you want to do, and then we will support you. So if you, for example, need a solar panel, or you want to add a solar panel to it, I'm not going to tell you that, oh, add a panel to it. That's what the judges have given you all the advice. Let us know, and with our partners through the CSIR Innovation Hub, and then our Clean Cooking Alliance, who are based in the States. And one area is the your presentation skills and mentorship. They will support you on that. So there may be some Zoom or Teams meetings with our partners from there. In October, some of them will be in Ghana before the finals to engage you. So we are going to provide. But the bottom line is, you need to come up with what you want to do. Otherwise, it's like me doing it for you. So take note of that. What we are also going to do is, we saw some of the projects. Some schools showed a video of how their projects worked when they tried it on campus. Others too told us, I think one of our girls, they mentioned that they did apply. Other people, the cuckoo people, the pre-seconds, whether the apply was correct apply or the cocoa was dried in Bono and brought to Presec, you and me were not there. So the commission will set up a team of experts to visit the 6 winning schools who go to the finals, and we will verify that what you said here today is actually what it is. So those who did the apply, who did the drying, who did all the various things, the cassava and the rest. Once you qualify for the finals, our experts will come and verify, and we will work with your teams and your various head teachers to do that. One other thing that I also want to say is, if in the course of your project, and I'm limiting myself to those who come to the finals, if there are things that you do during the process from now to get the finals, you can still take some short videos, 30 seconds, 1 minute video to show what you did, so that if something should go wrong at the finals, I'm not saying anything will go wrong, you would have something to fall back on, so that I want you to keep that in mind, so you don't find yourself wanting. I've talked about how we want to support you. So going forward, if you require any assistance, please let us know. Don't wait till the day before to come and tell us that, oh, Mr. Kansan, we need this. Oh, we forgot this. I remember last year, and this what I'm saying, we've seen it before. One school traveled from the region to the zone house, and I think they forgot their alcohol, their ethanol. And even me, I didn't know until that day that the concentration of alcohol in the ethanol in the northern part of the country is different from what we have in Kumasi and Accra. So if you think you're in Accra and you have been drinking alcohol and one whatever bottle, and it has been, you are still okay. If you go to the north and you try the same one bottle, you die. Because they bought the alcohol in Kumasi and it was diluted, so it didn't work for them. So there's an example. Whatever you need, any resources, all the logistics that you need, please, teachers, coordinators, let us know before time, and we will be available to support you. Another thing I want to say is what our science director always says when you are answering your questions. She has said it everywhere that she has been. When the question is asked, the first, sometimes what we hear is okay, and then you go on. No, that is wrong. I heard in some of the schools, okay, and I heard from some other schools too, saying, please, sir, thank you for your question. Then you answer. Let's take note of that. I think when we were in the regions, we made that known to you. When the question is asked, thank you for your question. Then you proceed. Not okay, and no. Please take note of that. It's very, very necessary. Because at the finals, we all know who is going to be there. The number one gentleman. So you can't look at his face and say, okay. Please, let's take note of that one. Do you want to add anything? Then let me add this with your presentations. You know you have 10 minutes. I didn't see much today of that problem. The aesthetics, the changeover, animations and all that. Please, this time I'm telling you, take them out completely. Take them out completely in your presentations. Just go straight to the point. And then also, when it comes to part of your presentations, the background, the literature review, for the finals, I would want you to concentrate more on the problems that you've identified or the issues in your community or in your environment that you want to solve, and then you dive in with the solution, what you are presenting, because the 10 minutes might be too short for you to say everything that you want to say. But in the process, we will be guiding you throughout the process so that you can get right thing done. There was one more. I think these are the main. Yes, I think one of the judges mentioned something in one of the presentations that the school should tell them about or educate them. Please don't assume, and I mentioned this in the originals, don't assume that we know. Yes, professor is here, engineer is here, chief physicist, they are here. Indeed, they know. But if you don't tell them, they assume that they don't know. And they are marking you only on what you have said. So I was partly excited and also partly angry when engineer Seth was pushing. I think there are some questions you ask about 3 times, so he will get the right answer. I'm like, if it was me, I will ask 1 time. When you answer, I'll take whatever you've answered as final. If it is wrong, I'll mark you wrong. Then you get 0/10 there. But then I think in that area, he was very soft. So he wanted to help so that you get the right answers. Please don't assume that they know. Say all what you want to say within your time, and then they will also do the needful. I think I'm done, and our judges, yes, they are nearly done. I can see one school getting 20. Which school is that? I can see another school getting 16.5. We are getting there. Infantile girls, how are you doing? Paje, right? Hey, boy, hey. I will say it in all the 16 regions we went to. You did it. Where man was an exciting environment when we went. I really enjoyed your school. So Bueman are here. Megis. Megis, are we there? The Presby boys. You are there. St. Francis, where are you? I always call St. Joseph, St. Francis. Where are they? Oh, you are here. Good. That's Peje, right? Peje. Yes, and to our girls. Yes, you are there. I like the way you people wave. Me, I wave like this. You are always skirmishes. And the last school to I've mentioned Presec, right? Hey, Paddy boys, you are there. Which school want to give me a few lines from the school anthem? Which school want to do that? You want to do that? Just the chorus. The chorus.
daddy here. This is the I wanted. That was
So you want us to be your daddy? Yes, okay. Yes, well, you want us to be what? Give us one liner. Hey, I'll start giving marks.
Trust.
I'm not who will tell you. Project. Yeah. Yes, so we have some girls.
God the Father, bless our school, bless our works and bless our play. Draw us evermore to thee. Make us love and serve away.
Wow. Which school want to go next? Giants. Do what the giants do.
Honor, O God, our leaders great, to whom you gave wisdom and power to build this glorious institute. So grant us, Lord divine, hope, strength, and love to cherish and uphold GSTS.
Thank you. Let's put our hands together for them. For what they've done. As the coordinator of this program, I'm going to give them 0.01 mark. Mr. Power, how many marks should I give them? I should give them more. Oh, you want to do it? Okay. Okay, right, I'm here. Who want to do it? St. Joseph. I did. Okay. Who called me? Good.
Maggie's girls, pride of the east. Stand firm, remain focused. Maggie's girls, pride of the east.
Wow, great. Well, then let's put our hands together for them. Infantile girls. I had to do it. It's not infantile girls. Infantile man. Hey, we shall arise. Those who know, they know. Just like a team in England called Manchester United. They shall arise. St. Joseph's.
The great Saint Joseph is a wondrous blessing. The fullness of knowledge liberates, that sings our alma mater. Lord God, our shield and our anchor, in you we get the fullness of knowledge that liberates, Arise, learn and truly serve with gladness and candor. Arise, learn and truly serve with gladness and candor.
Thank you so much, St. Joseph's. Now Infantine girls. Infantine girls.
Let them use this microphone. Okay.
So after Infantine, the next school get ready. If you haven't given your anthem, get prepared. McGee's.
Obranye warabo, warabo, warabo. Obranye warabo, obranye warabo, obranye warabo. Ufiti si oduman kumai. Obranye warabo teo.
Thank you very much. Manfi girls. Let's hear from you. Oh, you've sung. Okay.
Which? Just sing to wait.
Yes, let's go.
Here are we, studios are we, students of Presbyterian Secondary School. Onward we march, we trudge along to happy victory, to victory, to victory. Our motto is a soul propping us along. Illuminate, illuminate, to be the famous women. In the light, we shall see light. Illuminate. With the be Muslim men. For Christian training we get a sure solid foundation to take our places in the future of our country and church. For Christian training we get a sure solid foundation to take our places in the future of our country. Oh, come along and join us. Oh, come along and join us. Happy studios are we.
Thank you, but I wish you were not supported by your teachers. Okay. Who will sing among you?
You wish you come. Okay. Oh, great school, our mother school of beauty, how glorious is thy fame. Your emphasis just a mockery. How famous you are among schools. Thy names on the mountains and hills. How praises we offer thee. Oh dear mother school, blessed be thy name forever.
Thank you so much. In fact, we are all champions, but all of us cannot be champions today. At least some of them, some champions may come out from champions. But whatever it is, the National STEM Center, the National STEM Resource Center would like to take all other projects. We wouldn't have a good project and a bad project. All projects are put on the same scale. So projects that do not emerge as champions here, we would want to host those projects in a national science fair, national STEM fair. So please, coordinators, liaise with other projects that were in the preliminary stages, so that we bring all of them together in this important fair. Very, very, very important. And they will be given the needed publicity that they deserve. In fact, we have good talents, except that during the regional levels, we have to pick only one. We can't pick all the projects. So those projects out there are still good. Don't let them throw it away. We need them in that fair. Okay. Benisnote is ready. Obiniyam. Memo Yam Shisho, now be the first. Madam Benis, take over.
Hello, good afternoon. So I think we should all give ourselves a round of applause. You've done very well today. But as it says, it's a competition. So definitely someone must be first, and then someone, well, I can't say will be last. Someone will be eighth. So we'll start from the eighth position. Okay, so before that, you'll be going away with some souvenirs. So we have branded t-shirts, notepads, massets, and then you get flasks. The thermos flasks, yes, for your drinks when you are going to class. Then the plug is also going to the winning school for the Southern Zonal competition. So when you are called, when the school is called, I want the 4 students and the teacher to come up stage, and you watch the very first presentation so that we don't have to be telling you what to do for the next. So when you come up, the teacher will be the last to collect the certificates together with the souvenirs. So the students lined up, you'll be given the certificates one after the other. When you get yours, you move to the back of the teacher, to the back of the line. Do we all understand? Like how we did it for the regionals. Okay. So for the 8th position, we will call on Mr. Fred Ej Brobe, who is the senior officer in charge of the Ashanti Region Office of the Energy Commission, to give the presentation. So the school did very well, extremely well. They came out with 63.8 marks. 63.8 marks. Shall we invite St. Joseph's to come for this award? So I hope we are all watching the arrangements. Okay. So for the 7th position, we'll invite Mr. Emmanuel Oman Okwe. Mr. Emmanuel O. Okwe. Please take off your nose masks when you are coming. With 65.5 points, shall we invite Methodist girls? Oh, please clap for them. They've done very well. Take off your nose mask. Please, let's do it better for them. For the 6th position, we will invite Professor Francis Kemaso to do us the honors. With 66.3 points, Infantiman Girls. Central Region Coordinator, could you please join them? Yeah. For the 5th position, can we have Madam Ethel Linda Mensah to with 68.7 points. Women, please, the coordinator should join them. The coordinator should join them. So I think the first two presentations, the coordinators were not called up. So I'll kindly call on Mr. Fred Brobe to present the certificate to the St. Joseph's Western North Coordinator. Western North. Then Mr. Okwe to the Eastern Region Coordinator. So now we have divided the regions into two. Is that with 4 regions? Which regions are going to come to Accra? So we have Western, Ashanti, Volta, and then Greater Accra. Who is coming to Accra? Who is coming to Accra? Mr. Adams, tomorrow if I don't get my watch, you are not coming to Accra. This one year. So for the fourth position, we will have the coordinator for the schools challenge, Mr. Julius Nkansa Nyako, to give the award to that school who is not coming to Accra. The school who came forth is not coming to Accra. They are going to their school. So with 72.5 points, 72.5 points, this school is not coming to Accra. We have Presbyterian boys. So Presbyterian boys, although you are in Accra, you are not coming to Accra. Let's clap for them. Although they are in Accra, they are not coming to Accra. So we have 3 regions left. We have Western, Ashanti, and Volta. Who comes first? Who is first? Ashanti. I've told you, if my watch doesn't come tomorrow, you are not coming to Accra. Please, who is going to be first? Western Ashanti Volta. Ashanti. Okay. So for the third position, we have Engineer Seth Mahu giving the prize. With 74.2 points, this school is coming to Accra. And we'll invite Peje to come for the award. So the teacher plus the coordinator. Oh, the only female coordinator amongst the men. See, the ladies do it best. The only female coordinator. Please, let's put it out for them. The only female coordinator amongst the men. So, all the certificates, kindly leave them behind when we are done with the program. We'll have someone here to write your names on the certificates for you. So please leave your certificates with me. You get them either this evening or earliest tomorrow morning before you leave. So now we have 2 schools, 2 regions. Who is going to come first? Who is going to come second?
The school that can sing best.
Okay, so we are going to have a singing competition right now.
Yes.
So now we have Yasantua and then GSTS. Please rise.
GSTS cannot sing.
Please rise. Yasantua and GSTS. Who is going to take the trophy away? Where's the trophy? Is it going to stay in the Garden City or going to the west? The best is going to come from the west, or we are leaving it in the Garden City. Okay. So for the second position, we have Madam Olivia Opare, the Director for the Science Education Unit, to give the prize. So after we've announced the winner, please stay behind for your lunch treats before you go downstairs.
If we don't, we will eat.
So for the second position, with 79.3.
Infantipim School.
Oh, like 0.7 points, wait. 0.7.
Between the two?
Yeah, 0.7.
0.7.
0.7. 79.3. And then 80. 0.7.
Then add my point too.
And your point?
The point I was going to give.
The point
0.01.
Oh, stop.
And Mr. Boss said I should make it 1. So if I add my 1 to the second school, they'll become winners.
Oh. And we divide by 3. Okay.
Hey. Let me see.
So, we'll call on
the girls, the boys.
Oh, yeah.
I know this school.
No,
Hey.
school. Strictly
Okay,
girls,
let's
strictly
mix
boys.
them and then two, then they come to Accra.
So we'll call on the man who will buy me watch it tomorrow. Yes, Antoa.
Let's put our hands together for Yasantwa girls. Let's put our hands together for them.
With 79.3 points.
Let's put our hands together for them. Yasantwa Girls Senior High School. Please, those boys making noise, we will deduct you 2 points.
Students, are you ready?
Clap for the girls, clap for the girls, clap for the girls.
The sound they give you solar energy. Wind power, biogas and biofuel is a phase of our climate change. Back, 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 kaju, kaju, 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 back, back, back.
Please, let's put it out for them.
Project secondary, you are not clapping. We will demote you to number 4. I want to see you clap. Press boys, you not like clapping. If you clap more, I will promote you.
So we call on Mr. Kofi Ejapo to give the first position. With 80 points, the best going to the west, we call on the Giants.
Ghana Secondary Technical School. Can we all be upstanding as we welcome the winners of the Southeast Zonal Competition? JSTS. The Giants from the west. The Giants. The Giants from the west. Well done, JSTS. Well done, JSTS. Please, we can be seated now. You can take your seat.
The sound that gives you solar energy. Wind power, all that renewable energy. That's a body, that's a body, renewable energy. Unless I go to student, renewable energy, renewable energy, renewable energy. What is student you? The sound that gives you solar energy. Wind power.
We invite the dignitaries around to take a photograph with them. So the judges, Madam Olivia, Mr. Kansanyako, and Madam Linda.
Let's support the students. Let's support the young ones. Renewable energy. And let's support the students. Renewable energy. Renewable energy. Less about the young ones. I said less about the student. Renewable energy.
Shall we clap for them, please? They've done very well. So Western, Ashanti, and Volta. Western, Ashanti, and Volta. Western, Ashanti, and Volta. We'll see you in Accra.
Thank you very much, everybody. I can see some people want to reject their regions and join other regions. Mr. Penny wants to be from the Western region by force. Their neighbor. Hi, Mr. Penny. Okay. Thank you very much. I'll call on Mr. Kofi Jaku to very briefly give his closing remarks, after which we will descend to where we had the coffee break around the poolside for our lunch. Please make sure you pick your ticket from Madam Benes. Without a ticket, you may not be served. So make sure you take your ticket. And my dear students, please, happy or not, go and have your lunch. You remember what I said yesterday? When we get there, I'll make the announcement again. Because after 3 o'clock, we do what I said we will do yesterday. So we will all enjoy. So on this note, Mr. Jabu will give his closing remarks.
I want to congratulate all of you, the contestants. I think that you have put up a real fight, and you have done well. In a competition like this, there is no loser. The fact that you have traveled all the way to us, it means that you are a force to reckon with. So, congratulations to all of you. And comparing this year's competition with what took place the previous year, I can see a remarkable improvement in the way you do the presentation. Now I could see that the coordination was on point, and the flair, the style was also good, and it means that we are achieving one of the objectives of this competition, and that is encouraging you to learn to be very good public speakers and also to be able to deliver good presentation skills. You have done very well. And I'm also happy that for me the mistake I corrected last year was not repeated. So I'm very happy. If you recall, you were making some expressions on it, off it. And I told you that that one is the wayside mechanics expression. It's put it on and put it off. And this year I did not, it never surfaced. So I give it to you. You've done well. You've done well. It means that you are learning. We are all learning very fast. So, to those who are coming to Accra, I wish you Godspeed. And those who are not coming to Accra, the world doesn't end in Kumasi Sunset. It's always better to go back, prepare, and bounce back. God willing, next year we shall meet again. Come prepared and prove your mettle. Thank you very much.
Thank you very much, Mr. Kofi Jakon, Director, Renewable Energy. I'll call on Miss Esther Ade from Yasantua Girls to give us vote of thanks.
Thank you, Mr. Julius. Okay, so thank you to all the dignitaries present, the judges, the teachers, all school present, and to the Energy Commission. Thank you for giving us this opportunities to all schools to showcase their talents. And then we are really enjoying the facility, everything here. We are really enjoying, and we hope to see better. Thank you.
Thank you, thank you, thank you. And Ms. MC now become secondary MCU. Over to you. You can now close us.
Okay. I think God being so good, we have come to the end of the whole show, and we invite on the winner, that is the coach of the winning school, to give us a closing prayer. So, GSTS coach, where are you? Or you are outside jubilating? Okay. Then the second school coach, Yasantua. Okay, coach from Yasantua. Then after the closing prayer, there's one important hymn that the Director of Science Education likes so much, which we will sing. To God be the glory. We have come this far because of the glory of God. Yes, coach. Please, your name is?
Richard Owusu. Shall we be absent, please? Heavenly Father, we appreciate you for the day. Before we began this program, we committed it into your hands, and now the program has come to an end. There's to do the needful. We appreciate all the dignitaries who came, winning schools. We hope that those who also lost, nobody has lost. It's a competition. Some should come first, some should come last. So we hope that next year to be a better competition. In the name of the Lord we pray. Amen.
To God be the glory. Things he has done. That all may go in. Let the earth hear his voice. Praise the Lord, praise the Lord. Let the people rejoice. Oh, come to the Father through Jesus the Son, and give him the glory. Great things he has done. Praise the Lord, praise the Lord. Let the earth hear his voice. Praise the Lord, praise the Lord. Let the people rejoice. Oh, come to the Father through Jesus the Son, and give him the glory. Great things he hath done. Let's give God the biggest clap you can. And please don't take your certificates out. Bring your certificates so that they work on it and then give it to you later.
Okay, so the certificates Hello. Hello, with the certificate, the regional coordinators should take for their regions and submit them to Madam Benes. Collect them, each region should submit them to Madam Benes. You can kindly exit the hall and take your lunch ticket. Please, lunch is served. Exit the hall and take your lunch ticket.
Wind power, is the first of our climate change.
Please make sure you take lunch tickets. Okay, sir. Please, let's go for our lunch. Judges, let's go for our lunch.
Ayo. Yeah. Oh, I should start. Hey, go see. Hey, yes. Okay. I'm highly impressed. The whole program is very laudable. You know, we have core competencies so far as our curriculum is concerned, and energy, the school's energy challenge it has come at the rightful time in order to enhance the core competencies that we want our learners to have. Over here, looking at the presentation skills, our students have really exhibited that, and it will lead them to become good leaders. So communication, collaboration is excellent so far as this challenge is concerned. When it comes to critical thinking and then innovation and problem solving, we are within. So the program is highly, it's a very good one. Yeah, my advice to schools that couldn't make it to the top, especially schools present here, it is a project. You know, this is a project and it is a challenge. Another chance could be given for you to go and improve. Your project wouldn't end here. You can always improve, and I bet you will make it to the top in the near future. Cheer up, you are winners. Coming this far makes you a winner, so you are a winner. And like Mr. Bauer said, very soon we'll be having National STEM Festival, and your project will be invited for display. Thank you so much.
Okay, so this is Santoa Girls Senior High School, and this is the Renewable Energy team representing the Ashanti region. Okay, so during the competition, we've been through a lot of competition, the prelims, the regionals, and this is the zonals. During the regionals, we became first for our region, and then during the zonals, we were second. We thank God for whatever He has done for us, and we thank our teachers, our schools, the Energy Commission, and everything. Expect us at Zakara, and we are assuring you we are going to win. We are going to win. We are taking the trophy to Santoa Girls Senior High School. Thank you.
Thank you so much.
Our general impression.
Yes, your general impression. How was the competition? Was it fair? You know, of course, you say it's fair because you are fair. What we should expect from you, and what you would also tell your other friends who couldn't qualify? I think you remember them. So can you stand in the middle?
We are very happy right now, and we give thanks to our God for granting us victory. Indeed, victory comes from our Lord. Our impression, after the program, we had little confidence that we were going to win. But indeed, our God has been good to us. What we are going to do after this level, we are going to make all the manual controls replaced by voice controls and hand gestures. And we are also going to make sure that we are going to get a very high temperature from our solution. And also we are going to find a way to control the focal points that gets under our cooking pot to ensure that food does not get burnt when cooking. What else? Okay. Now the information I'll give to the other schools who then qualify is that they shouldn't get demotivated. They should continue working on their project, and finally they'll sail through and then become part of the finals. Thank you.
The Energy Commission in cooperation with the Ghana Education Service presents
the third edition of Energy Commission High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. at the Sunset Hotel Kumasi.
The competition aims at fostering an interest in renewable energy among students of the second cycle institution.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Clean Cooking Alliance, Friends Development Agency, and the Volta Laboratory.
We are passionate about the next future generation. Education Service and
the third edition of Energy Commission Senior High School Renewable Energy Challenge.
It's happening on the 20th and 22nd of August 2022.
Time is 9 a.m. to 1 p.m. Other sunsets will come March.
The competition aims at fostering an interest in renewable energy among students of the second cycle institutions.
This event is brought to you in collaboration with the Ghana Education Service and sponsored by the German Agency for International Cooperation, Think Cooking Alliance, French Development Agency, and the Volta Republic.
We are passionate about the next future generation.